operations professionals to intuitively transition whiteboard models into reliable queries in seconds, deriving insights from connected data quickly and efficiently. With Cypher, users can simply express what data to retrieve, declarative, while the underlying engine completes the task without requiring them to understand implementation details. With Cypher, you can easily follow a chain of relationships to an arbitrary depth and return the full path or even the shortest path. You can combine reads and writes in a single statement, allowing you to select data to update and to return updated data directly to the customer. Query pipelining is easy using with and implicit grouping to simplify aggregations and multi-part analytics queries. If you are ready to dive into the most widely used graph query language, Neo4j has plenty of resources to explore. Learn more at neo4j.com/product/Cypher. Are you interested in graph data science but don't know where to begin? The Neo4j Sandbox is the best way to get started and learn graph data science basics with interesting preloaded datasets like fraud detection, contact tracing, and Twitter trolls. It's easy to jump right in, follow our guides, and explore visualization with Bloom. There's no download required, and you can get up and running in less than a minute. Try it for free today. Introducing Neo4j 5, ushering in a new era in graph technology that is transforming the way we use connected data. And with this latest update, Neo4j is more powerful than ever. You want enhanced performance? Neo4j is unmatched in the market. Neo4j was already 1,000 times faster than relational databases, and with version 5, Neo4j widens the performance lead with new features like K-hop query optimization, graph pattern matching, and granular indexes. You want your data to scale? With 5, Neo4j has unbounded scalability. Autonomous clustering lets you scale out horizontally with less manual overhead and better use of computing resources. And when your datasets lie in multiple databases, Fabric instantly helps you create a composite graph of insights hidden in disparate silos. You want agility? Neo4j 5 has unparalleled operational agility. Neo4j fits your IT strategy, whether it's on-premise, cloud, hybrid, or multi-cloud. And with Neo4j Ops Manager and a continuous release support model, it's easier than ever to manage your database in the cloud. Neo4j 5 helps you achieve unbounded performance, scale, and agility. Find out more at neo4j.com.
Your machine learning models are working. You're seeing results, but you know there's more for you to uncover. What if you could use the network structure within your data without disrupting your machine learning pipeline? With graph data science, you can. Here's how it works. You load your data into the Neo4j graph database, which reveals the connections in your data. Then you ask questions using graph queries and uncover hidden patterns in your data using graph algorithms. For example, similarity and community detection algorithms examine the network structures in your data to uncover tightly knit communities, such as fraud rings. Then you can use graph feature engineering to extract predictive elements to augment your machine learning models. Now you have the power to make better predictions from existing data. To learn more about graph data science, visit neo4j.com.
Twenty of the 20 top financial institutions in the U.S. trust Neo4j to solve previously unsolvable challenges and to see new patterns in existing data. Why? Relationships are the core of your business and drive everything you do. Whether you need recommendations, customer 360, client onboarding, fraud detection, or machine learning, relationships are fundamental to all of them. Neo4j, the world's leading graph database, makes these complex tasks easier and faster than traditional databases by putting relationships first. Moreover, graphs are a high-fidelity way of representing what's important in your business as they are designed to mimic the way the real world works. Neo4j's graph data science gives you the fastest path to bring graph analytics to production, and with AuraDB, Neo4j's fully managed cloud service, you can get started in minutes and easily scale on demand. Find out more at neo4j.com. Neo4j is the #1 database for connected data, built from the ground up to leverage not only data, but also data relationships. Neo4j is a native graph database, which makes it critically different from other data stores. But what does native even mean? Neo4j is designed around a simple yet powerful optimization. Each data record, or node, contains direct pointers to all the nodes that it's connected to. These direct pointers are called relationships. All the information needed to find the next node in a sequence is available in the node itself. The native storage layer is a connected graph. That's what native means. Because of this principle, Neo4j doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of densely connected data are orders of magnitude faster. Other databases don't save direct pointers between records. They need to compute connections by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is extremely expensive and gets exponentially slower as the data size and query complexity grows. This makes them inherently slower than Neo4j for relationship-intensive queries. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, gain a 360-degree view of data, and much more. Learn more at neo4j.com.
Users generate 2.5 quintillion bytes of data per day. A staggering 55% of that data is left untapped, with even more data stored stripped of their relationship and context. This means that the need for an intelligent data visualization tool to make sense of rapidly growing, unconnected data has become nothing short of essential for driving innovation and business transformation opportunities within organizations. Neo4j Bloom, a graph data visualization product from the creator and leader of graph database technology, is here to help. A Neo4j graph database empowers developers and data scientists to uncover data context for deeper insights, better decision-making, and faster innovation, making organizations go from data-driven to intelligence-driven. Neo4j Bloom is a beautiful and expressive data visualization tool that allows developers and data scientists to easily visualize and freely interact with Neo4j graphs. Bloom also makes it simple to translate complex data concepts and findings for less tech-savvy stakeholders. Want to analyze a particular graph property of interest? With Bloom, simply go from generating a friendly search phrase to investigating your results and sharing with colleagues. Need help identifying malicious network traffic using large volumes of data but not sure where to start? Bloom gives you a head start by helping you generate hypotheses as you explore complex data. With Bloom, users can filter and add more data, view algorithm results, stylize data, and much more. Best of all, Bloom's codeless search paradigm makes visualizing data even easier with a few key phrases. Out of the box, Neo4j Bloom works across many domains requiring graph analysis, including fraud detection, network analysis, supply chain management, and much more. Discover meaningful value from your data and open new paths towards innovation and business transformation with Neo4j Bloom. Get started now for free on neo4j.com/bloom.
Graph embeddings are a new technology that learns from your data, revealing new ways to solve problems and adding visibility to your business's blind spots. Real-world uses for graph embeddings include finding fraud, improving recommendations, entity resolution, discovering new drugs, or predicting churn. To get in on the cutting edge of graph technology, learn more at neo4j.com.
Michael, you're live.
I know, but it's not arriving in Hopin. If you can see that. Or is it? So 1 second. I'm not 100% sure that I'm live. I just want to check that everything is correct. So got it. Okay. Okay, thank you. So sorry for that. Good morning, everyone. I'm really excited to start the next section of nodes, this time for the Asia Pacific region. And I'm so excited that you're all here. It's really early in here in Germany, 3 in the morning, but I'm super excited, super pumped to see you all coming, and let's get started. So I just thought it would be really cool to see what else happened today or yesterday. So the Artemis mission to the moon launched, and GitHub added Cypher highlighting as well. So you can think about how long these projects both took and which one is actually actual rocket science. Also, Neo4j Workspace is now available on Neo4j Aura for all new users, including interactive guides and having this really nice combined interface for all 3 apps. But there's also, of course, the option to switch back in your profile to the classic 3 app experience. And Neo4j 5 itself is generally available in Aura and desktop, including the Graph Data Science Library, APAC, Core, and Extended, and all the user tools as well. What else happens today? Oh, yes, Nodes. So welcome to Nodes. Very warm welcome to the biggest online graph technology conference of the year. I fondly remember when we ran the first Nodes in 2019, when our team came together in Sweden to run the first event, but we would have never dreamed that it would grow to such a big event around the world with so many people attending. So it really warms my heart to see this growing so much. And actually, if you look at how many people are attending Nodes, so this is all the attendees of Nodes, and you are in there somewhere. If you really kind of squeeze, then you might find yourself. First of all, I want to start by thanking all our speakers, without whom this event would not have been possible, but also our community partners who helped us spread the word, our amazing Neo4j team who built all this event and prepared everything and is running things behind the scenes. And of course, you, the attendees, without whom a conference would be pointless as such. So Nodes is a 24-hour event this year. So we ran the first session for the Americas already. Now we are starting at 8 a.m. Indian time. And we have more than 100 talks by 113 speakers, which are all very interesting. When we put together the schedule, we were really impressed by all the high-quality content that we got in. And there are more than 9,000 people for the event, which is really, really impressive. We want to make Nodes this year a really inclusive educational event, so there's a lot of focus on education, and that's why we've focused all the talks on kind of teaching new things, sharing experiences, and so on. That also is represented in the tracks that we have. We have one beginner track, which has content for people who are new to graphs, an intermediate track for people who have already started their graph journey a little bit. And for those graph experts and pro, we have also a full track with content. And between all these tracks, there are lots of lightning talks for all kinds of topics. And especially proud about Anton's meditation session. So we ran it already in the Americas, and it was a full success. And so if you want to take a breath in between, join Anton's mindful meditation session. That's always good. Looking at the UI, What you can see today is the stage already. So you're watching already kind of me on the stage here. On the right side, you can ask the questions to the speakers. Please ask a lot of questions. We had a lot of good engagement and questions in the Americas. And I think that's really great. And of course, please rate the sessions in the polls that pop up after the talks. In terms of topics, we have a lot of different topics, from developer topics like app development, GraphQL, Java, Python deployments and things so on, to data science, graph neural networks, but also just graph data science, social network analysis, machine learning, link prediction, and things like that, to things like operational deployment. We have Kubernetes talk, Docker talks, how to deploy GraphQL APIs and so on, cybersecurity talks, things like that. And then use cases, of course, everything from healthcare to fraud analysis to deep learning on real data to other things. The most important questions of today I want to answer up front. Yes, everything is recorded. Yes, you will be able to watch it later. And yes, you will also get the slides. And you can watch all the talks from every time zone whenever you want. Right? So there are no restrictions in terms of that. We also want to encourage really people to connect with each other. So that's why this platform has a networking tab on the left side, which allows you to go there and chat with other attendees. So you can basically just go there, get matched up with others, and then you can basically chat for a few minutes and then pick someone else. So it's kind of like speed dating, but it's a really great method to learn about new people, what they're doing, what they're working on, what excites them about graphs or technology in general. And this is really good. Way to go. We also have an goodie bag area that's not a traditional expo area with exhibitors, but we have a goodie bag where you can get, for instance, like a second or maybe free instance, free ebooks, and a free t-shirt. And the free t-shirts is actually coming with a Twitter competition that I'll talk about in a second. At the end of each section, Emil and Andreas, our co-founder, and Emil will answer all kinds of questions. So you can ask your own questions to Emil, which is a unique opportunity. So use this. We had a really good session already. So use this tab on the right that says Ask Emil in the Events tab and put in your questions. And we also ran a Twitter contest. So if you watch a talk, see something really cool, take a screenshot, share your thoughts, tag the tweets with Notes 2022 and hashtag live tweet, and then you can win one of 20 special t-shirts as such. And with that, I leave you. Enjoy the conference. I hope you learn a lot of things, exchange with other attendees, share on social media, and for the keynote, so we already ran the keynote in the US, but it's really good. That's why we thought we want to repeat it in the other sections as well. There's this really, really great book called Connected, which talks about or is about applications of graph technology in human society. And one of the authors of Connected, James Fowler, actually spoke in 2012 at the first Graph Connect conference. And today I'm really excited to have Nicholas Christakis speak at Graph Connect, at Nodes as well. And he will talk about the application of network science to humanity and lots of his research. So welcome, Nicholas, and let's get going.
Thank you, Michael. Thank you so much for having me at Nodes this year. I'm very grateful to be here. So human beings are embedded in social networks. And these networks obey very particular biological, psychological, sociological, and mathematical principles. And taking this into account offers us tremendous opportunities to gain new insights into behaviors and also to change them. We can use an understanding of social network structure and function for good, to intervene in both online and offline worlds in order to enhance our health and our well-being, our public policy, and our business objectives. And in the broadest possible sense, taking human embeddedness in networks seriously shifts our focus to the externalities of interventions. That is, it engages us in an exploration of how it is that when we intervene in a group, we affect not just the people that we target, but also all the other people around them. I'm interested in real social networks, the kind we humans have been making and embedding ourselves in for tens of thousands of years, and not just the recent online variety. Real social networks look like this. Every dot is a person. Every line connecting them is a relationship between two people. Who's whose friend, who's whose coworker, who's whose sibling or spouse or neighbor, for example. And these social networks are intricate things of beauty. And they are so elaborate and so complex and so ubiquitous, in fact, that one has to wonder, what purpose do they serve? Why are we embedded in them? How do they form? How do they work? And how do they affect us? And I've spent the last 20 years researching how and why human beings form social networks and how they affect our lives, our health, our desires, our feelings, our thoughts, and our actions. Now, part of this work has involved exploring the biological predicates and consequences of social networks and the evolutionary basis for social network structure and function to begin with. Social networks, you see, afford the people within them different possible structural positions. And I'm going to introduce these ideas right now, and we'll return to these basic points. There are a number of mathematical ways we can understand what it means to be in different parts of a human social network. But three of the simplest ways are illustrated on this slide. First of all, there's the number of connections that an individual has. So once again, this is a network. Every dot is a person. Every line represents a relationship between two people. And if we look at this network, we can see that node B in the upper left is different than node D on the far right in that they have different numbers of connections. B has 4 connections and D has 6 connections. This is known as the degree of a node, this number of connections, and people know this about themselves. People know how many connections they have, for example, or at least they can know it. But now we, with this bird's eye view, can see that there are other possible structural locations within the network that individuals might not be able to appreciate about themselves. For example, if you compare nodes C and D, C is in the middle of the network and D is on the periphery, they both have 6 connections. And if you talk to those two people, that might be the limit of their understanding of how many connections they have. But we, with this bird's eye view, can see that C and D are very different. And I can cultivate this intuition in you by asking you, who would you rather be if a deadly germ was spreading through the network? You should have the intuition that it's better to be D, that D is going to get whatever's spreading later in the course of the epidemic, if they get it at all. Conversely, who would you rather be if a juicy piece of gossip were spreading through the network? You'd rather be C. And because you have the intuition that C's in the thick of it, they're going to get whatever's spreading sooner in the course of the epidemic and are more likely to get it. So this property is called the centrality of a node, how central the node is in the network, and this can be quantified mathematically in a number of ways as well. Last, if you look at the nodes on the far left, A and B both have 4 connections. But the difference between the two is that B's friends are not connected to each other. They're not friends of each other, but A's friends are connected to each other. This is known as the transitivity of a node, whether your friends are knit together or not. And this might also affect your fate in life. Your ability, for example, to work together in a group might depend on whether your connections are in turn connected to each other. Now, one early project that we did in my laboratory was to look at the extent to which these 3 properties are heritable. This graph shows the extent to which this is the case. On the y-axis is the percent of the variance that's explained, or the heritability, by your genes. To what extent do your genes explain these properties? And on the x-axis is the 3 properties. And on the far left, what we show is that 46% of the variation in how many friends people have can be explained by their genes. Now, this is not very surprising. People vary. Some people are born shy. Some people are born gregarious. People vary in their taste for friendship. But we also found that 47% of your transitivity can depend on your genes. And this is one of the more bizarre results to come out of my lab in the last few years. Because what I've just told you is that if Tom, Dick, and Harry are in a room, whether Dick is friends with Harry depends on Tom's genes. Whether those two people over there are friends with each other depends on my genes. How can that be? Well, we think the reason is that people vary in their tendency to introduce their friends to each other. Some people knit the networks around them together, and some keep their friends apart. And last, if you look on the far right there on the centrality, 29% of the variation in how central you are in the network can depend on your genes. We think this is related to whether you have a predilection for befriending popular or unpopular people. If you befriend popular people, then you want 4 popular friends, I want 4 unpopular friends. That'll put us in different positions within the network. So the fundamental reality of our desire for connection and our susceptibility to social influence, it turns out, has always been with us. Where you are in this vast fabric of humanity depends in part on your genes. And our lab has been amassing evidence that it is indeed not a coincidence that we form social networks with particular mathematical properties. We've shown that there is an evolutionary significance to and heritability of social network structure and function, and that phenomena like peer influence, how we affect each other, and homophily, the fact that we tend to prefer the company of people we resemble, are of fundamental significance. Across evolutionary time, it seems that the benefits of connected life must and do outweigh the costs. Now, if social network structure has genetic antecedents and significance, it begs the question of how ancient this structure is and whether we might be able to document such structural features in human populations living in non-industrialized settings. In other words, the fantasy experiment we would love to do is to say, well, okay, could we fly back 10,000 years ago and map the social networks of our ancestors and see what kind of networks they made? Obviously, we can't do that. So we hit upon what we think is the second best thing, which is to map the social networks of the Hadza hunter-gatherers. The Hadza live in around Lake Eyasi in Tanzania in the ancestral human environment. They live like we did during the Pleistocene. They hunt and they gather for their food. They have no material possessions to speak of. They sleep out under the stars. And there are only about 1,000 of them left that live in this very ancient way. So what we did is we prepared a photographic census of all living adult Hadza using 10 years of field photographs. And we printed them onto these posters like a kind of Hadza Facebook. And we went into the field, and every time we could find a Hadza person, we asked them to tell us who their friends are. And we therefore painstakingly mapped the social networks of the Hadza. And we found a number of things. First of all, we found that Hadza networks look, both mathematically and visually, just like ours, just like modernized networks. In other words, despite the fact that in the last 10,000 years, we've invented agriculture, we've invented cities, we've invented telecommunications, the networks that we make are just like theirs. You see, network structure likely, and this is consistent with the very ancient origin of network structure and consistent with its partially genetic basis. Now, while we were there, we also found something else. This is an image of the Hadza network among women in the Hadza. Every dot is a person. Every line, again, represents different kinds of social relationships. We make the dot size and color related to how generous and altruistic people were. We had the Hadza play what is known as a public goods game. We gave them some resources and we said, if you share these resources with your neighbors, we will double those resources and you'll get back a fraction of what you shared with others. So you have to pay a little sacrifice. You have to make a little sacrifice, but everyone else will benefit more. And so the yellow dots are the high donation people, the more cooperative people. The red dots are the low donation people. They're known as defectors. And if you look at this, you can see that there are clusters of nice cooperative people and mean defector people located within the social network. And this clustering of cooperative behaviors within the social network is also consistent with the ancient significance of human social networks. I'll come back to this with some experiments in just a moment. Now, in a parallel and early stream of work that we also did in my lab, using both observational and experimental methods, we and others have provided evidence that a variety of behaviors and phenomena beyond germs spread within our networks, beyond just dyadic ties. In other words, when you affect your friend, when you influence them in some way, your influence doesn't stop there. It keeps rippling through the network. And the challenge is to document that, to document the extent of that and the reasons for that. And across a wide variety of phenomena, we found that people's influence tends to spread to 3 degrees of separation, to your friends' friends, and your friends' friends. And that this happens for a variety of phenomena, like obesity, smoking, drinking, and drug use. with emotional states like happiness, loneliness, depression, or behaviors like altruism, like I just showed you in the Hadza, or with things like criminal behavior or voting or purchasing behavior or ideas. People's attitudes, decisions, and behaviors depend in quantifiable ways on the attitudes, decisions, and behaviors of others to whom they are directly or indirectly connected. A key idea about networks is that networks magnify whatever they are seeded with. If you put something in a network, the network functions like a kind of social magnifying glass. It makes more of it. But the network is agnostic. It doesn't care what you put in it. Networks will magnify Ebola or COVID or fascism or violence or fake news. But equally, they will magnify love and kindness and happiness and productivity and ideas. But something has to impinge on the network to get the process started. Now, of course, there's more going on than just this kind of social contagion I just alluded to. For instance, in the case of the contagion of obesity, several things might be happening. For example, the first thing that might be happening is straight up social contagion, or what you might also call induction, or a social domino effect. I gain weight, it makes my friend gain weight. My friend gains weight, it makes my friend's friend gain weight. There's a kind of spreading process in the network. Another possibility is that it's not my weight gain that causes your weight gain. Rather, it might be that birds of a feather flock together, or homophily, which is love of like. Maybe I befriend other people because they have a similar body size to me, or similar taste in exercise or in foods, for example. A third possibility is that it's neither that my weight gain causes your weight gain, nor that we form a connection because we have a similar body size, but rather that we share an exposure to something like a gym that makes us both lose weight, or a fast food joint that makes us both gain weight at the same time. And all three of these are typically present in any social phenomenon. For example, why are people buying a particular product? Are they buying a product because their friends are buying that product? Do people who like that kind of product preferentially form attachments to each other? Or is the marketing campaign of the firm really effective at getting many people to buy the product? So it takes effort using diverse statistical and experimental techniques to tease these sorts of effects apart. Here's one early experiment that we did to isolate social contagion. In this experiment, groups of college students were brought into the laboratory and they were randomly assigned into groups of 4 strangers, these little boxes of letters shown on the left-hand side here. And they were given a little bit of money and they were told that if they gave $1, let's say, to their group, we would double that dollar so that the group would gain $2 of wealth, and each person would get 1/4 of that because there are 4 people in the group. So you give $1, you get back 50 cents, but your group gains $2. So obviously the best thing is for everyone to give maximally. This is called a public goods game. It's an economic model for human altruism. The best is for everyone to give maximally. But of course, from a selfish point of view, what you really want to do is give nothing and hope that everyone else gives. But of course, if everyone thinks that way, nobody gives and then nobody benefits. So what we did is we put these people into this type of a challenging situation, and they played one round, and then a bell would ring, and they would play another round, and a bell would with new people, then they'd be randomly assigned to new people. Then a bell would ring, and they'd be randomly assigned to new people and play again. And as a result of this, we were able to create simple artificial linear networks where we could trace back the sequence of interactions that previous individuals had had. And what we were able to find is that this kind of altruistic effect could spread from person to person. So for example, what we found is that if Eleni is kind to Lucas in period 1, Lucas is kind to Erica in period 2, Erica is kind to Jay in period 3, and Jay is kind to Brecken in period 4, a kind of cascade highlighted in red on this slide. And this is another one of the most bizarre results to come out of my lab in the last few years. Because what I've just told you is that how Jay treats Brecken depends on how Eleni treats Lucas, even though neither Jay nor Brecken ever saw or interacted with Eleni or Lucas. How 2 members of this audience treat each other may depend on how 2 other members of this audience treat each other, even though neither pair ever interacted with any other member of the other pair. So this is an experimental documentation of social contagion. And this geodesic through the network spread of altruism is distinct from the temporal persistence of altruism highlighted in yellow. In other words, if Eleni is kind to Lucas in period 1, Lucas learns to be kind. And he's kind to Erica in period 2, and Lysander in period 3, and Bemi in period 4, and so on. In fact, if you fold back all the downstream benefits, for every extra dollar that Eleni gives Lucas, the network functions like a kind of matching grant, doubling the downstream benefit. Or one other way of thinking about this is that pay it forward is real. Now, to be clear, we are affected in another way by social networks. It's not just what's happening around us that matters. The actual structure of the network also matters. Think about these two objects that you all studied in high school chemistry. They're both made of carbon. And on the left, you have graphite, which is soft and dark. And on the right, you have diamond, which is hard and clear. And there are two key intellectual ideas here. First of all, these two properties of softness and darkness and hardness and clearness aren't properties of the carbon atoms. They're properties of the collection of carbon atoms. And second, which properties you get depends on how you connect the carbon atoms to each other. Connect them one way, you get one set of properties. Take the same carbon atoms and connect them another way, you get a completely different set of properties. Similarly, the pattern of our connections affects the properties of our social groups. It's the ties between people that make the whole greater than the sum of its parts. New properties such as cooperation and violence, health and happiness, innovation and productivity can emerge because of the connections, because of the ties between people, and not necessarily because of the people themselves. So it's not just what's happening to the people around us that matters, whether they are happy or rich or thin, for example. Our experience of the world also depends on the actual structure of the ties around us, near and far. Let me give you one of my favorite examples of this. This is some work done by my colleague Brian Utsi, who became unaccountably interested in the success or failure of Broadway musicals. And he put together a data set of 326 Broadway musical production companies. And he mapped the social interactions of the teams producing these Broadway musicals. You know, the director, the producers, the musicians, the actors, and so on. And he computed something very similar to the transitivity that I introduced a few slides ago. So on the far left, you have, let's say, 6 people. You have the person in the middle. There are 5 people to whom that person is connected to. And there are 5 times 4 divided by 2, 10 possible connections among those people, but none of them are present. So you have 0% density on the far left. In the middle, 4 of those 10 connections are present, so you have 40% density. And then next over, all 10 of those ties are present, so you would say there's 100% density. And then he plotted in the cartoon on the far right, he plotted the density of the social structure of the ties among the members of these Broadway musical production companies on the x-axis, and on the y-axis, he quantified the success of these Broadway musicals. Now, Broadway musicals take hundreds of millions of dollars to make. They're high stakes, high risk business ventures. And he quantified the success either in terms of the money that they made or the fraction of positive reviews. And he found this parabolic shape. In other words, towards the lower end, towards 0%, if nobody knew each other from before, the show was a flop. And at the upper end, if everybody knew each other from before, the show was a flop. Optimal innovation and productivity was achieved in the middling range of density, where maybe some people knew each other from before and could work together effectively, and other people were fresh, brought in fresh ideas, and created a new chemistry in the group, which allowed the group to be more productive. So these sorts of observations have suggested to us 3 broad ways to intervene in networks so as to enhance public policy and in various ways, to use social networks for good. We can manipulate connection, which is change the structure of the network. Or we can manipulate contagion, which is to change the flows through the network. And finally, in a way I'll come to in a moment, we can manipulate position, which is to change the location of individuals within a network. And there's expanding science in all 3 areas using both online and offline settings. And I'd like to give you a feel for some of our results. These results are all from experiments, but we have other findings as well that from observational studies that I won't be presenting today. So over the last few years in our lab, we've developed software that we call Breadboard that allows us to easily recruit test subjects, including on Amazon Mechanical Turk or other settings, and create temporary artificial societies of real people. So we can, in a kind of godlike way, socially engineer different social arrangements, seamlessly recruit research subjects, drop them into these little worlds, have them interact with each other, pay them money for their trouble, and then experimentally manipulate these in order to test ideas experimentally about social organization. By the way, we've made this software publicly available. It's at breadboard.yale.edu. Here's some work involving the manipulation of connection that I mentioned that illustrates both the use of the software and this principle of the importance of social connection. We took hundreds of research subjects. We randomly assigned them to different worlds in which they were dropped into networks which obeyed different rules. On the bottom, we dropped, and then they played multiple rounds of a public goods game across time. 10 rounds, for example, is shown on the bottom, where it says 1, 2, 6, and 10. That's the round number. This game took about 40 minutes to play. So in the bottom row, people were dropped into a fixed network. They were dropped into one of the network structure was determined, and they were assigned a location as shown by the blue and red dots. And the color, and then they were given some money, and they were asked, would you like to share this money with your newly assigned neighbors? If you do, we'll double the money, everyone will benefit, but you have to pay a little price. Of course, you hope that your neighbors will reciprocate, or you can defect. You can be a red dot and not contribute and hope that others contribute. And what happened in that branch of the experiment was that about 2/3 of the people were nice blue dots, cooperative, altruistic, kind people at the beginning, but they were taken advantage of by their red neighbors who abused them. And so why should you keep contributing if your neighbors are mean to you? You start defecting as well and also not contributing. And across time, what you find if you trace out the lower row is by the end, everyone has converted into a defector. You've got a sea of red dots, except a few blue dots on the edge of the network, keeping civilization alive. In a different branch of the experiment, however, in addition to asking people whether they wanted to, and by the way, that branch of the experiment is typical of the kind of experience many of us had in high school when the teacher randomly assigned you to be with some people and in a work group to do a project and said, you're all going to be given the same grade, you have to work together. And if you were assigned with people who were lazy or incompetent, you had two unpleasant choices. Either you could do all the work because you wanted a good grade and they would get credit for having done nothing, or if that annoyed you, you would also stop working and then everyone would get a bad grade, including you. That's the dilemma faced by the people in the bottom row. In the top row, however, in addition to giving the people the option of whether in this public goods game, whether to be generous to their neighbors or not, we also gave them a little bit of ability to manipulate their social connections. At each time step, they could cut ties to people who were defectors or form ties to people who were cooperators. And in that branch of the experiment, as you can see, cooperation persists. So in other words, I could take a group of you and randomly assign you to one regime of social connection, and you'll be really sweet and nice to each other. Or I take the same people and assign you to a different regime of social connection, and you're mean jerks to each other. So it's not who you are that matters. It's how the network is organized and structured that might elicit this property of cooperation, just like the carbon example I mentioned a few minutes ago. In a subsequent experiment, we explored the parameter space of the rewiring rate, this social fluidity that I mentioned a moment ago, whether you could break or make ties using hundreds of subjects in dozens of groups. And on the y-axis, on the x-axis here, we put the rewiring rate from 0 to 100%. 0% rewiring means you're in a rigid network, you have no control over your social connections. 5 and 10% means a little bit of control. 100% means every time step, every one of your social connections is up for renewal or can change or does change. And then in the middle is everything in between. And on the y-axis is a regression-based estimate of how cooperative the groups are. And here you see a parabolic shape. What this says is that if you're in a rigid social structure, cooperation is low. And if you're in an overly fluid social structure, cooperation is low. And the optimal cooperation is achieved in a middle range. This sounds like the result with transitivity that I told you earlier, but it's completely different. This is not transitivity, this is social fluidity, which again has this parabolic shape. And I can cultivate an intuition in you in this by asking you to think about different kinds of institutions we have in our society. For example, the kind of institutions related to marriage. If you live in a society in which marriage, no divorce is possible, on the far left, social rigidity, once you pick your spouse, you're stuck with your spouse forever. If your spouse is mean to you, your choice is to be kind to your spouse forever and have them take advantage of you, or to also become mean, both of which are unpleasant. But meanness rises and sweetness declines in that kind of regime. At the other extreme, if you constantly have a new spouse, if every day you're assigned a new spouse, there's so much fluidity, you have no incentive to be nice to your spouse because they're not going to be there tomorrow. So what you want is a regime in which divorce is possible, but not too easy. You want a set of institutions that move people into middling levels of social rigidity. And I would suggest the same kind of thing happens with work groups in businesses and firms. You don't want overly rigid work groups, but you don't want overly fluid ones either if you want to optimize cooperation and actually other properties like innovation within these groups. Here's still another experiment of ours, a more recent experiment. This was published in 2015, manipulating another feature of our social interactions, namely whether we can see each other's wealth. This is a complicated experiment with many results, but let me give you some highlights from this experiment. Once again here, we dropped people. We recruited hundreds of people into dozens of groups. Actually, there were 1,400 people in this experiment who were put into these artificial societies. We gave them real money to play with, and we randomly assigned them to be rich or poor, and we have a lot of money or little money, and we randomly assigned them to be in either unequal, very unequal, slightly unequal, or very equal social worlds. For example, here on the left, we assign people into a very unequal social world, which is measured by the Gini coefficient, which is a number that goes from 0 to 1, and it's 0.41 on the lower left. That's a very high Gini that has a high level of inequality, like Morocco or the United States, for example. And then the dot size is proportional to how much wealth people have. And then we put a little letter, R for rich and P for poor, which is what you're assigned at the beginning, the amount of wealth you're given. And then in one branch of the experiment, in the invisible condition, people now start playing the same public goods game I've been telling you about. And the color of the dots indicates the blue dots are the nice cooperative people, the red dots are the mean defectors. And they play multiple rounds of this game. And you can see in that on the left-hand side of this slide, in the invisible condition, that by the end of the game, many things have happened. The inequality has plummeted from 0.41 to 0.14. That's actually below Scandinavian level of inequality. All the dots are big. Everyone has gotten rich. And most of the dots are blue. Most of the people are cooperative. That seems kind of nice. In a different branch of the experiment, we flipped a switch and those people were put in the visible condition where they could see their neighbor's wealth in addition to their own wealth. And in that branch of the experiment, none of those outcomes obtained. The inequality stayed high, 0.38 and 0.36. Most of the dots were red defectors, and you don't have as many wealthy big dots produced on that branch of the experiment. So making the wealth of others visible was bad in this situation. And here's a summary of some other results from the same experiment shown differently. On the x-axis, we have the rounds across time as people play these games. And on the y-axis, we have the average wealth produced in these societies. And we had a 2x3 factorial design. We had 6 branches of this experiment where there were 3 different initial inequality conditions: no inequality in blue, low inequality in red, high inequality in yellow, and then 2 different visibility conditions, Dotted line, the wealth was invisible. Solid line, the wealth was visible. And if you can look at this slide, you find that actually, unexpectedly, actually, in my case, the inequality didn't seem to corrupt or affect the ability of the group to produce wealth. But the visibility really did. When you made the wealth of others visible, you decreased the ability of the society to produce wealth. And the same kind of finding was obtained with respect to how cooperative these societies are. Here again on the x-axis is the round number. Now on the y-axis, we put the proportion of people who are cooperators, and you find the same results where inequality doesn't really affect people's cooperativity, but visibility really does. Now, these findings have implications for all kinds of policies in our society, everything from pay secrecy in firms or sports teams or school uniforms in schools. I used to be very much against school uniforms for various reasons. They struck me as kind of fascistic. But when we did this experiment, I began to kind of think of school uniforms as a kind of cloaking device, a kind of invisibility cloak that, maybe had the students focus on other things rather than on competing in terms of how wealthy they were, manifesting their wealth, for example, or social status. Here's another result on the importance of network structure, because we become interested in the sharing economy and in ways to optimize it. And we built a game that captures, now this is a more recent experiment, that captures some pertinent features of the challenges of sharing. Imagine wireless routers in people's homes, and that people can share the excess capacity when they don't need it. They leave their house, the neighbor can use their wireless capacity, but then when they come home in the evening and their neighbor's away, now they can borrow some of their neighbor's capacity. And in this game, people had to choose whether to share a resource that was essentially useless to them with their neighbor in the hopes that their neighbor would reciprocate. And using this scenario, we assessed how satisfied people were, and we randomly assigned people into two different network structures. And again, this is a complicated experiment, but the gist is kind of powerful in my view. Here, there are two different networks that are drawn on this slide. Both of these networks have 15 people. Both of these networks have 18 total connections. Even more than that, both of these networks have the same distribution in the degree of connections between people. For example, that little figures that are shown on the left there, if you look at how many people have one connection, 6 people have one connection in both networks. How many people have 2 connections? 3 people have 2 connections in both networks. How many people have 3 connections? 3 people have 3 connections in both networks. And how many people have 5 connections? 3 people have 5 connections in both networks. You basically couldn't tell the difference in which of these two worlds you were in. Same number of people, same number of ties, same number of people with the corresponding number of ties. And yet, when we drop people into these networks and have them play the Wi-Fi sharing game, you get completely different levels of satisfaction according to whether or not the network is organized to be assortative or disassortative. In an assortative network, popular people are connected to popular people and unpopular people are connected to unpopular people. In a disassortative network, it's the opposite. It's like an airplane network. Hubs are connected to small cities. So in a disassortative network, popular people are connected to unpopular people and vice versa. And what we found was that the assortative organization which is what humans do, humans are organized in assortative networks, was optimal for satisfaction in this situation. So structure again matters, just like the carbon example. And we can engineer different structures of human groups to optimize different outcomes. Now, moving on, we can also perform experiments that manipulate contagion. For example, this is a paradigm of experiments we're conducting that illustrates how you might manipulate contagion, for example, in sets of villages, or in sets of firms, or in factories, or in work groups, or in classrooms, for example. Imagine you have 2 villages, the one on the left and the one on the right, and you have just enough money to target 6 people, the 6 yellow dots, with a public health intervention. For example, to teach people how to use a latrine, or a vaccine intervention, for example. And the ordinary perspective in public health is you give those 6 yellow dots the intervention, and you come back a year later and you ask, well, how many of those 6 people adopted the intervention? Maybe 3 of the 6. But that's not what I'm interested in. I'm not interested in response to treatment among the treated. I'm interested in response to treatment among the untreated. When you go into this village and you give those 6 people the intervention, I want to know what everyone else in the village does. Maybe you target those 6, you give them the public health intervention, 3 of them adopt, and maybe 3 of their friends also adopt, for a total of 6 people in the right-hand village, and in the control village, maybe 2 people adopt the practice. But now you should be thinking, well, maybe I shouldn't pick the 6 people at random. Maybe there's an intelligent way to pick the 6 people so I get more bang for my buck. And the answer is that that's true. Instead of, for example, picking 6 people at random, maybe you should pick 6 central people. Maybe you target 6 people again, maybe 3 of these people adopt, but maybe they persuade 30 of their neighbors to adopt. Same village, same intervention, same number of people targeted, 10 times the effect, because you have shrewdly used mathematical algorithms to target structurally influential people within the village. And then you can experiment with all kinds of algorithms, which is one of the things that my lab does. For example, one of the algorithms we use is an algorithm known as the friendship paradox. And this is the idea that your friends have more friends than you do. This is a mathematical fact about social networks. And I can cultivate this intuition in you by asking you at least to consider the people on the periphery of a network. For example, that person on the very far right there has 1 connection. That's why they're on the edge. They only have 1 tie, but their friend necessarily has more than 1 connection. In this case, 2 connections. And in fact, if you look at the bottom yellow dot at the bottom of the slide, their orange friend has 8 connections. And so for everyone on the periphery, their friends will have more friends than they do. It turns out this is a mathematical fact everywhere in the network. On average, your friends have more friends than you do. So if you pick the 6 yellow dots at random and take 1 random step to one of their friends, to the orange dots will have higher degree and higher centrality on average. And the reason this is fantastic is that you can find the orange dots without having to map the network. So now you don't have the cost or headache of doing it. You just pick 6 people at random, ask them who their friends are, and you give the intervention to their friends. And we've been doing this in a number of settings around the world. For example, in Honduras, where we work in the western highlands of Honduras, it's a very poor part of the world. People live on less than $2 a day. We have mapped the networks. We have another kind of software that we use called Trellis. This is which we make publicly available at trellis.yale.edu. This is tablet-based software that can efficiently map human social networks in the field. And in our first experiment, we had 32 villages, and we mapped the networks, and we randomly assigned the villages to 3 different targeting algorithms. And in 1/3 of the villages, 5% of the people, in all the villages, 5% of the people were chosen to get the intervention. In 1/3 of the villages, 5% were chosen by chance, randomly, to get it. In another 1/3 of the villages, 5% were chosen who had the highest degree. And in another 1/3 of the villages, 5% were chosen with the friendship paradox technique. And what we found is, so the question was, if you want to move a whole village and not just individuals to change their behavior, how do you do that? Who do you target? Who creates the most externalities for behavior change? And how can you exploit that? So for example, here is how the targeting of 2 nodes might vary in one set of villages. The orange dots are 5% chosen at random, and the yellow dots are 5% chosen so as to be the people with the highest degree. So same village, different targeting algorithms, you can get a visual sense of the different people that would be chosen. And what we found in this experiment is that by using the friendship nomination technique, here on the x-axis is the days since they were targeted with, in this case, a multivitamin intervention. On the y-axis is the proportion of people that adopted the multivitamin intervention. And you can see that the nomination targeting strategy dominates the other strategies. So this is an illustration of manipulating social contagion. Finally, here's a recent experiment that involves manipulation of position. Now, just to give you an intuitive feel of what this is about, imagine you're a teacher and you have 20 desks nailed in front of you, and no one's seated in those desks, but the desks are nailed to the floor in a particular arrangement, and you have 20 students outside of the classroom with varying abilities. The question is, given that structure of interactions that the nailed desks on the floor allow, which student is near which student, where should you position the students in this network of desks to optimize learning in the classroom? Maybe you should put all the better students in the front or in the rear, or mix them up, for instance. This is a position intervention. How should workers, for example, be organized within a firm, given the same workers, given the same job functions, given the same organizational arrangements? Who should go where to optimize the performance of the groups? So this experiment explores this idea of a position intervention, and also explores some other ideas involving artificial intelligence. So here what we did is we're exploring the ability of a group of people to solve not a cooperation task, but rather a coordination task. They're dropped into networks, and they are told they have to pick a color dissimilar from their neighbors, orange, yellow, and purple. And they're told that if they work together in this team over the course of 5 minutes, and they can change colors as often as they want, and they can all of them work together to converge in a solution where everyone has a color dissimilar from their neighbors, they'll be paid as a group. Otherwise, they get nothing. The point is they have to coordinate, they have to work together. And so on the upper left, at the beginning at 0 seconds, you can see that people are dropped into the network. They're given initially a random color. The red lines indicate who's in conflict with their neighbors. The purple connections indicate that there's no conflict. If you look in the upper left, you'll see there are 2 orange dots that are connected, and they have a red line showing that there's a conflict. You should have the sense that the dot on the very far left, that orange dot, if they turn to purple, they would eliminate the conflict with their neighbors. That's a smart move for them. At the bottom, we show the progress through the game. Time is on the x-axis. The number of color conflicts is on the y-axis. At the beginning, there are 12 color conflicts, and that everyone starts picking their colors and working on the game. And by 105 seconds, they've almost solved it. And you can see in the middle, there are 2 yellow dots, and now the group is stuck. They can't make a move that allows them to solve the problem. If one of the 2 yellow dots either picks orange or purple, they will increase the number of conflicts in the graph. But interestingly, that's what they have to do. They have to make a counterintuitive move. And in fact, that is what happens. And by the end, at 245 seconds, the graph is colored and the people are able to solve the problem. Now, in this experiment, what we did is we evaluated what we call hybrid systems of humans and bots, of humans and artificial intelligence players, and how it might be to work together, and how we might be able to add bots with certain kinds of programming to human social systems to make them perform better, and how the position of those bots within the system might affect what happens. We manipulated a couple of things in this experiment. We manipulated how the position of the bots, and that's shown on the rows. On the first row is the bots were put at random. So we dropped 3 bots into these systems. There were about 15 or 20 people. I'm sorry, there were 20 people and approximately 3 bots in each group. We had over 4,000 people in 210 groups in this experiment. Sometimes we dropped the bots in a random position. Sometimes in the middle row, the bots were put in the middle, in the central position in the network. And sometimes in the bottom row, they were put in the peripheral position in the network. In addition, we manipulated the behavior of the bots. In the first column, the bots had what we call 0% noise. At every 1.5 seconds, they looked at their neighbors and they picked the color with the least conflict with their neighbors, every 1.5 seconds trying to minimize conflicts. In the middle column, we gave them a little bit of noise. So every 1.5 seconds, they picked the color with the minimum conflict, but 1 out of 10 times they picked a color at random. And in the final column, they had 30% noise, which is 3 out of 10 times they picked a random color. Now, on the on these 9 squares, on the x-axis is the time in seconds, the duration of the game, and on the y-axis is the probability that the group has not solved the coordination game. The orange line shows the sessions with humans only, the control group. And you can see that at the beginning, the humans, and the orange line is the same in all 9 of these squares. At the beginning, 100% of the human groups have not solved the problem, but they work their way through, and by the end, 2/3 of the human groups have solved the problem. However, if we add 3 bots with a little noise, 10% noise, in the middle, we can substantially improve it, as shown by that purple line in the middle square, which a larger fraction of the groups is able to solve the problem. So bots with 10% behavioral noise added into the middle of social networks, a little bit of kind of random behavior in the middle of this group helps this group of people solve the coordination problem. And in fact, the humans learn to play better by having bots among them. And what's happening is that the bots are helping humans to help themselves. And we're building on this work to design and add simple bots to these and other situations involving social dilemmas and collective action problems. We're looking at ways to enhance the ability of groups' coordination, cooperation, communication, evacuation, navigation, and sharing by experimentally adding bots to these groups. And by the way, it's not just about inventing bots to add. When we do these experiments, we gain insights into what humans could do in human-only groups to make it easier for humans to function in these types of situations. What we're doing in my lab, in a sense, is exploring simple kinds of programming, what we call dumb AI, that might make human groups more effective. We're not focused on developing super smart AI to replace human cognition. We're inventing dumb AI to supplement human interaction. And because these dumb agents are added into collections of smart humans, the agents don't have to be that smart. They just have to help a little to help the humans to help themselves. Okay, I'd like to close with one final idea that'll take a couple of slides. And it has to do with what it means to intervene in a social network, because I think such interventions provide us with a way to manipulate social capital. And to understand one sense of this, consider this idea. What's a point of a connected life? Well, how does it help us as individuals and as a species? And it turns out that networks are a resource that we can all use. Networks are a kind of social capital. Now, most people, when they think about capital, think about money. But really, capital is any stock of resources that can be put to productive use. So capital is a reservoir of wealth that you can produce something with. And 2 further key ideas about capital are that in order to create capital, you have to invest skill and effort. You have to know something and do something in order to create capital. And second, and more subtle, and an idea that's been keeping me awake for 20 years, is that in order to create capital, fundamentally, what you have to do is make changes in a substance that make it yield a higher rate of return than it otherwise would. That fundamentally, the capital creation process is actually about the transformation of the natural world. What do I mean by that? Well, look at this idea. A farm is a stock of capital. By investing skill and effort to clear the forest, you make the land more productive of fruits and vegetables and grains and flowers, for example. And so you've transformed the natural world. You've transformed a forest into a farm, and you've endowed it as a reservoir of wealth, as a source of productive power. So land, especially improved land, is a form of capital. Or you can take this tree and you can invest skill and effort and mill it into lumber. And the lumber is more valuable than the tree because you can do things with the lumber you couldn't do with a tree. Namely, invest still more skill and effort and make a violin. And the violin is more valuable than the lumber because you can do things with a violin that you couldn't do with a lumber. Namely, make music. So at each step of the way, you invest skill and effort, and you transform one thing into another thing, and you make it a stock, a reservoir of wealth, and a source of productive power. Well, a key innovation in thinking took place in the 1960s to see people and their skills and talents as a form of human capital. And the chief example of this is education. If you endow someone with skills and knowledge, you change them and you make them more productive. Like you can take this dissolute former graduate student of mine on the far left, who's a drunkard, and you can invest skill and effort and clean him up. And now he's more productive and able to do things he wasn't able to do before. Or you can invest still more skill and effort and give him an education. And now he's still more able to do things than he was able to do before. Well, just like physical capital is created by a change in the material world, and human capital by a change in persons, social capital in organizations, in companies, in villages, in communities, indeed in our whole society, is a change in the relations among persons, a change that renders the group more productive and capable of doing things it was not previously able to do. And that is the deepest account I can give you of what social networks mean for our lives and why it is and how it is that we can use them to make the world better. Thank you very much.
Wow, what a splendid start to the day. We are here in the beginner track. Can I have some love for the keynote speaker, please, Nicholas, in the chat window? That's right, it's coming. That's what I'm looking for. More emojis, yes. Awesome. So we are all set to bring in our first speaker for the day today. In the beginner track, I'm your host for the beginner track today for the APAC region, and I have with me John Stitchman. John is going to talk about workspace in AutoDB and how to easy on ramp up on using graphs. Over to you, John.
All right, thank you, Sid. Good morning, everyone, and those of you who may be straggling over from the West Coast of the U.S., good evening to you. I think I probably have the hardest presentation of this session to present after Dr. Nicholas presenting there. I think that was super exciting. It was the second time seeing it, and I even learned even more the second time watching it than the first. So my name is John Stegeman. I joined Neo4j a few months ago this summer. People call me Steggy or Stegosaurus. It was my childhood nickname, so you can call me what you like. Today I want to talk really quickly about something called workspace in AuraDB. Now, those of you who have been working with Neo4j in the cloud probably know what AuraDB is, but some of you may not. AuraDB is our cloud offering. So it's a database that you can use freely in the cloud. There's a free version, and then there's versions that have more capability and larger and larger servers that you pay for, of course. And so, what is Workspace? Let me talk about first what I would call the current experience, which you may have already experienced. If you've used Neo4j, you've probably seen these three tools that are on the screen in one form or another. On the left, something called Bloom, which is used for visualizing and exploring the graph in a visual way, give that big picture of the data and how it's connected to each other, and dig in and really understand visually how that data looks. There's something that we call Browser, which is our query tool, so that you can write Cypher queries and really shape that data that you're returning, see that data either visually or see it in a tabular format. And we also have a newer tool called Data Importer, which lets you take file-based data and import it into a Neo4j graph database. And each of these tools today, if you go into Aura today and don't do anything, you'll see three buttons in AuraDB. You'll see an explore button, which corresponds with Bloom. You'll see a query button that corresponds to browser, and you'll see an import button that corresponds to data importer. And in fact, we could just jump over and take a look right now. This is my AuraDB console. I've already created a couple of databases, and you could see what I just described. We've got Explorer, which is Bloom, Query, which is browser, and Import, which is the data importer. So what's this thing called Workspace? Well, Workspace is simply us taking these three tools and combining them into a single interface. So rather than having to, click on another button and then sign back into the database and do this context switch, if you will, we now have all the tools under one roof, so to speak, so that you could sign on once and access all of those tools together. So, and that's what we call Workspace. And so Workspace today is available to anybody who would like to try using it. It's not fully there yet, so we're kind of calling it as an open beta, and I'll explain why it's in beta, what might be missing for those of you who want to use it. But to access Workspace, it's really simple. Once you've signed on to the console, you can click on your profile, and you should have the ability to switch over to the new interface that we call Workspace. And just with a simple click, you can see now I no longer have three buttons that I need to go jump from one to the other. Let me just copy my password, and I'll give you a quick tour of how to navigate around Workspace. So we'll sign in one time, excuse me, and we'll start off in the Explore tab, which, as I said before, is Bloom. And if those of you who've used Bloom before will be really familiar and comfortable in this. The way I like to get started in Bloom, if you've never used it before, is just to click the question box up on the upper left here, and then just click Show Me a Graph. Or you could just type Show Me a Graph. What Show Me a Graph does is it just executes a query to get some sample data back from the database. It's just a representative data to help you start exploring. And then you could zoom in, you could do all the things that you're used to doing in Bloom. By the way, what this database is showing here, it's the Stack Overflow sample database that you can create in AuraDB. And if you've never used AuraDB, hang around for the next presentation, which I'll show you how to access AuraDB and spin up a database like this. And all the things that you can do in Bloom standalone, you can do in here. We can select related nodes and select everything that might be related to a question here, etc. So I'm not going to go into the real details. There's a session in the America track that was recorded that you can watch, which is a much deeper dive into the capabilities of Bloom. Now, if I want to use what we call browser, here in Workspace, we call query. I could just click on the query tab and then start writing my SQL queries. So just something as simple as match and relationship to you. Yeah, very, very simple, write a query, just like you could do today in browser. And one little trick, if you're new to Neo4j database and you've got an existing database like this that you'd like to find out more about, you can do something called call.db.schema.visualization inside of browser. And you get an idea of what your data model looks like inside the browser. So you can see we've got user nodes, we've got question nodes, tags, and so forth. And then finally, the data importer. Data importer, as I said before, was a way to take data that exists in files on your operating system, CSV files, TSV files. And I'm just going to go grab some here and give you a quick run of how this looks. Let's say I've got some movie data. Those of you who've been around Neo4j know we like to use movies and actors and directors as sample data. And I've just dragged those CSV files in, and I can now start mapping nodes in the data importer to data in that CSV file and get that imported into the database. So what I've shown you is something really simple, and it's what we've done is we've taken 3 tools: browser, Bloom, data importer, which were 3 separate tools, and we brought them together under a single user interface, really just to streamline the experience. Now, I said before it's in open beta. What might you miss if you were to use browser versus the individual tools? Right now, Bloom and Data Importer, to the best of my knowledge, those are on feature parity with the existing versions. The piece that's not quite on feature parity yet is the query tab. Is not yet achieved feature parity with browser. So that's the only reason that it's in beta. So again, if you'd like to use this, log on to your ORDB console, go to your profile, and you could switch using the little switcher here, and you can go back and forth. Those of you who do go out and use it, be sure to give feedback. You know, if you notice something that's not working, or you notice something you like, notice something that you think would make it better, jump out and give us some feedback. And one more thing, let's just check the time here. We've got just 2-3 minutes. If you'd like to find out some more about Workspace, my colleague JT has just dropped within the past 24 hours a playlist on YouTube. It's got kind of a long URL up on the top there, but if you've got your camera handy on your phone, just scan that QR code and it will take you right to YouTube, and you could watch these. You could see here it's about just 10-15 minutes of videos where JT will talk about Workspace and give you a little bit more information in a deeper dive. So with that, let me just glance over at the question. Sid, I think we have just a few moments here. Mona, I think you found it. Yep, it's up on the profile, up in the upper right. So just to show that again, I've got my picture here. You drop down, that's where you can switch over to Workspace. So with that, the slides will be shared, video will be shared, and if you'd like to stick around in about 5 minutes, those of you who never used AuraDB before, I'll show you what it's like just to get started with AuraDB. Thank you. Sid, over to you. Or maybe not. So with that, I'm going to stop sharing while we're waiting for the next session to start. There he is. Hey, Sid. You're on mute.
Oops, my bad. Thank you. Thanks so much, John. Should we get started with the second one?
Yeah, give me just a moment, because what I wanted to do is to destroy my free instance
Right.
so that I could show people how to create one. So if you give me just a second, I'll go ahead and share my screen again, and we can jump right in.
That's good. Meanwhile, folks, to connect with other people who are joining in on the stream, send in your questions to John in the Q&A section. While you are doing that, John, would I like to take up one question, which is by Tom. Is there anything you can share about the future direction of Bloom, short-term, long-term?
Yeah, that's a good question. I'm probably not the best person to answer that. I do know that one of the things I remember in the session on the Americas track earlier today about Bloom, where you talked specifically about some improvements or some new things coming in Bloom, and that was the integration with graph data science. So Bloom I've shown you, 0.1% of what Bloom can do here in this really quick presentation. But one of the things you can do with Bloom is to surface a visualization of some part of your graph or all of your graph, and then run some data science algorithms against that. We have a couple of, I think, network centrality, and then there's a couple of, I can't remember, there's 4 algorithms in total, and I apologize, it's escaping me what the 4 are. But one specific new bit of feature that I know we're working on is exposing more of those algorithms from within Bloom itself.
Got it. Sounds good.
And you may want to, oh, there we go. Michael, thank you very much. Yep, he is referring to the earlier presentation that was on the other track. You may want to jump over there. It's a full 35-minute session on Bloom if you'd like to have a look.
Thank you.
Yep. And just there was one more question, Lydia. I'm not sure I understand your question. You're asking, can I open the workspace? I'm not sure. You might, if you'd like to clarify your question in the questions there, maybe we can get you a better answer there.
All right.
All right. So let's move on to the second talk here. In the second talk, we're calling easy on-ramp to graphs. Now, why do I call this an easy on-ramp to graphs? If you're like me, let me share a little bit of my history. As you probably can tell by the little gray in the mustache here that I'm growing for Movember, I've been around for a few years. My first job experience where I did something where I had to use a computer language, I used Fortran. My second language was SQL, and my third language was Smalltalk. So of those, I imagine there's people in the meeting who have used SQL, but there's probably substantially fewer who've used Fortran or Smalltalk. But at any rate, I tend to be a very hands-on. When I've got some software, let me get it on my computer, let me install it. And as you know, with any database, there's hardware requirements and software requirements. And today, I just don't want to deal with that sometimes, right? I just want to get started. I want to get up and running. Maybe I don't have a powerful enough laptop to run a database, or for whatever reason, it would just be easier for me to spin something up in the cloud. And so that's why I'm calling this the easy on-ramp. This is all about AuraDB, which is a way for you to spin up a database in the cloud for free. It'll be perpetually free. It's not something you're going to get charged for. It's not a time-limited trial or anything. It's a free version of Neo4j Graph Database that you can run in the cloud and get your hands on and start experimenting with it. Now, I've only got one slide for you here. And the slide really is the link that you go to. If you go to this link, and in fact, if you just search Neo4j AuraDB, you'll get a link, to this page. Just go right to the middle where I've got the arrows there and click Start Free. You'll need to create an account, sign in if you haven't done that before. Once you've done that, we'll take you right over to the console. Okay, you've seen the console before. Excuse me. If you haven't created a database before, you'll just end up with a blank page here with no instances. In my case, I already have one, but for a new user, you just click on Create Instance or New Instance up there in the top. And as you can see here, up on the top is where your free database options are. Down on the bottom, you can see there's a professional instance, which is something where you want to scale up from the free instance, maybe get some more capacity, run on larger servers with backups and all that kind of good stuff. There's that as an option, but let's focus on the free options. Now, maybe you want just a plain empty database with nothing in it to get started. You can click at Empty Instance here. For us, let's go and jump in. Maybe we want one with some movie data in that. You simply click one of those options. What we're going to do is we're going to create that database instance for you. While we do that, I'm going to copy the password and paste it over here in my other window. So we're going to create that database instance. Make sure you copy this password, by the way, because this is the only chance you get. And it'll take a few minutes for it to spin up. Now, while that spins up, rather than wait here what the next steps might be, we're going to jump over to the pro instance that I have created here, which is an empty database, and we'll come back to this one in a minute. So within a few minutes, you'll now be able to just jump right in and start using that new database that you created. Here on our side, let's go over to an empty database that we have here. Remember, here on Workspace, I need to get the correct password for that. Here we are. Go right back into Workspace. And I had started working on this before, so let's go ahead and add those files back in. There we are. So what might I start doing? If I've already got some data, maybe I've extracted it from a relational database, or I've got some file-based data that I want to load in and start experimenting with, I can use the Neo4j importer, the data importer. And what I've simply done is just taken a few CSV files from my laptop here, and I've dropped them into the data importer. I'm not going to go through a really deep demo of the data importer. We just don't have the time to do that today. But really simply, I can just start adding nodes here. In my data, I've got some movies. So maybe I want to create a movie node. That movie node will be mapped to this particular CSV file. From that CSV file, I'd like to have these properties: movie, title, budget, countries, et cetera, et cetera. I'm not going to go through, as I said, and do everything here. Once I've done that, I can continue mapping the other files. So I've got a people over here. So let's go ahead and add a people node. I'll call it a person. So again, really similar. We can add persons. We can add some properties here. We can create relationships between them, etc. Like here is a relationship. Maybe we have a relationship where a person has acted in a movie. And you can see I have a CSV file over here that contains those relationships. And when we say here, okay, we need to, before we can do this, we need to identify what the ID property is going to be of here, down here on the bottom. So the ID of this person, we'll use that ID. The ID of the movie, we'll use that ID. And then for the relationship, we can say from person to movie. Here, really simply, just kind of a point and click without having to write any code. We could import that data into our database. We can do a preview, which will give us a quick visualization of what that graph would look like. Kind of an approximation of what that's going to look like, and then simply run the import. And what I'm doing here is I've now taken the data. I haven't mapped everything, but I've just done a few things here and have imported 93 movies. I've imported 444 people, and I goofed up somewhere in my relationship. I didn't get any relationships created, most likely because I clicked the wrong ID on the wrong side of the relationship there. But once we've done that, we can now just jump straight over to start exploring. We can run queries. We can go into Bloom and see what our data is. So here we are in browser or the query tab, and you can see there's the same exact data that we saw. So why is this useful? I'll tell you, it was really useful for me when I started at Neo4j. As I say, how do I get started? How do I learn more about the graph database and start exploring it and writing my own queries and dealing with my own data? Rather than installing any kind of a software, just pop open a browser, jump off to OraDB, and we'll go back here again just to give you that URL and the QR code if you'd like to save that. And really quick way for anybody who's never used a graph database before to get up and running. Now, the other question you may ask yourself is, okay, great, I've got this graph database. I'm really not sure what to do with it. I don't know anything about graph databases. I just need some quick education to teach me what to do with the graph database. And for that, the easy thing to do is just to Google Graph Academy. And I'm sure Michael or somebody's going to be dropping a link here in the chat. And if they don't, I'll do that. That is free, online, self-directed training where you can go to there, learn about Cypher, how to write queries, learn about data importer, learn about how to model your graph, and learn how to use this graph database effectively to do the kinds of things that you want to do. So with that, really simple, let's have a look at the questions here. I think we have 5 minutes. Is that right, Sid?
Yeah, that's right.
Gotcha. So really, how does one add their picture to their account? That is a good question, and I actually believe this question came because I signed on with my Google account. Okay, so that picture, I'm guessing, it's been a few months, so I apologize, I don't know, I can't confirm this, but I'm pretty sure that that's my Google profile picture, and that just automatically came over. Yep.
Great.
Mona, question, will OraDB have APAC installed automatically? good question. I know that APAC, I'll be having another talk in about, gosh, how long is it from now? About 7 hours from now, where I'm going to talk about some of the new capabilities in Aura and Neo4j 5. I don't know the answer to that question. Maybe somebody on the call does. Mark, your question on a public endpoint. Yes, it is a public endpoint. We don't, I believe, have any specific security on that endpoint. Thank you for putting the question up there. However, one of the things we do have with AuraDB is the ability to use the name of the cloud feature is escaping me right now, but it's essentially virtual private connect in all the major clouds, where you essentially can connect that directly to your VPC and access AuraDB only through your VPC. So in a corporate environment where you need to secure that obviously is something that you would want to use. Michael, thank you for the link there. Other questions? I'm looking over at the other side here. I think we've got all the questions answered. Any other questions?
No, I think those are the questions that we have from the audience.
All right, so thank you, everybody. I've enjoyed, I hope what I've shown you here today in these really quick sessions are just how easy it is to get up and running in AuraDB in the cloud, and to start using a graph database that maybe you've never used before.
Yeah. John, before you go, I think there are 2 more questions that just popped up.
Yep,
we have time, we can take them up.
Yep. So Andrews, the database is in a, so you're going the opposite direction there. Save Cypher queries in the Bloom. Will they will find those saved queries? Yes. So the saved, when you say saved queries in Bloom, I think you probably mean you're talking saved scenes in Bloom. Those are actually saved into the database itself. So if somebody is logged in with that same user, they should see them. If they're not seeing them, then you can raise a ticket with the Aura team to get some support on that, but that should work to the best of my understanding. And Andrews, the database is in a single node. Yes, it is in a single node. In version 5, again, I'd suggest for some of these deeper questions, especially when we look at sharding and clustering, to attend probably the Neo4j 5 for administrators session that was in the Americas session, and view the recording in there where we talk about some of the new capabilities with clustering and sharding in 5. But those capabilities will be exposed through APAC as well. By default, you're getting a single instance here, but there are, those capabilities will be coming to the Aura platform as well.
Splendid. I think we are right on time. Thank you.
All right, thanks.
So much, John. It was
everybody.
A really
enjoy
session.
The rest. Yep. Thanks, Sid.
Thank you. All right, so coming up next is my dear friend Shiny. Shiny is developer advocate at Neo4j, and he's going to talk about exploring the relationships between people in the Asian Chinese novel, Three Kingdoms. Over to you, Shiny.
Hi, Steve. How are you?
I'm good.
Yeah.
All the best.
Yeah, I'm so excited to be here, and yeah.
Likewise.
Let me share my screen. Okay, thank you, Steve. And yeah, my talk's title is Exploring the Three Kingdoms with Graph Skills. If you haven't heard about the Romance of Three Kingdoms, that is the traditional novel from ancient China, and you will find the novel online and about almost everywhere, you think. Yeah, so let's get started. And Yeah, just before my talk, I'd like to introduce more about myself. My name is Jenny, and you can find my Chinese name on this slide. And I'm a developer advocate from Neo4j. You can follow me on Twitter. This is my Twitter handle. And the below is graph about my career, and I started my developer career from a travel agency, and I was a developer who built the front-end website for them. And years later, I started build back-end services, server-side programming, like that. And after years, I moved to an e-commerce company, and then I moved to another company. It was an air travel company. I almost work on the database and mobile and many other projects. So I mark myself as a full stack developer. And in the graph, the other 9 is from the community. I am active in the developer community, the open source community. I was containers at Microsoft MVP for 11 years before. Yeah, so the path across into the developer relations. So yeah, that's me. Topics in this talk, I want to cover about the novel itself, the romance of the 3 kingdoms, and I want to show you how to build a people graph from the novel, and I will show you use Neo4j ORDB and workspace to explore the knowledge graph, and I will share with you some takeaways and main points of my talk, and what you can do next. Yeah, just a little about the Romance of 3 Kingdoms. It's very famous in China, but I don't know if you have heard about it. If you haven't, please search 3 Kingdoms on Google, and you can find many images and even the novel itself, and many books and TV shows, even movies, I think. Yeah. It's about the ancient history. 3 forces are competing to the nations, I think. Yeah. So let's look at a little more about the novel itself. There are 120 chapters of the novel, and there are many characters in the novel, about more than 1,000 persons there. Yeah, and you can find the novel raw text in the by the link on the slide. Yeah. So today I will use the raw text to build a people graph. The novel is in traditional Chinese text, and there are it don't looks like other data provide an API or something like that. It's just the raw text. So we will extract the data like people, like their relationship, like interactions from the raw text. After that, we're going to model the people graph and import the data into our Neo4j ORDB database, and so that we can start exploring the graph. Yeah, let's get started. So I will show you the code. Yeah, here is the Neo4j ORDB. You just learned about that. ORDB provides a free tier. And you can see I have a running free tier instance. So let's start with the import tool. It's the Neo4j data importer. Let me put my password. Okay, I will clear my. Yeah, as you just learned about the workspace, and workspace contain data importer, Neo4j browser, and Bloom into a single tool, but you can still access the data importer and the tools separately. So here is the data importer. Yeah, I will start with modeling the people graph with the data I have already extracted from the raw text. I will introduce how to extract the raw data later. Yeah, that's should be the hardest part. Yeah, sentences. Okay, sentences LDP and links LDP. Here are the files we need in the people graph. Yeah, like you can say, the sentences of file contains every sentence in the raw novel, and the names CSV file contains every person's name in every single sentence. So I can link them, link person name into sentence. So let's start modeling. Yeah, I will first put a chapter. Yeah, you should remember there are 120 chapters of this novel. So from the properties, I will select chapter order and chapter name for the chapter node. The ID, I can specify the chapter order property. Yeah. Yeah, the data importer will help us create a constraint on this property. Okay. Next, I will create a sentence node from the same CSV file, and yeah, the sentence column. Yeah, you can just specify the sentence column as its unique constant. You can see here is a relationship between chapter and the sentence. I will reverse the direction. Sentence in chapter. Yeah, that's the type of the relationship. And from sentence, yeah, it's a sentence. And to chapter order, yeah, that will show us a sentence belongs to a chapter. Yeah, here's a very simple model. So I will add another node. Our name is person. Let me see. From the names CSV file, and select person name as its property, and also the unique constraint. Yeah, we know that the person from the raw text, they appears in every sentence, every paragraph, and yeah, we will name this relationship is mentioned in a sentence. A person is mentioned in a sentence. Yeah, that's the relationship. And from person name to sentence. So yeah, okay. Here is our very simple model. So let me click the preview, and you can see how the graph looks like. The blue node is a chapter node. You can see there are many sentences around it, and you can also have person nodes here, and they are mentioned in a sentence. And say a sentence can contain many persons in a single sentence. Yeah, looks great. So I will click the run import. You can see the progress here. The data importer is importing the data to the Neo4j DB instance. It should take a few seconds. Okay, done. And you can say chapter node, sentence node, and person node here. And in chapter, mentioned in relationships here. And also you can check the query, the Cypher query here. So as I said before, it helps us create a constraint for the nodes. And here is the node data queries. Yeah. So what's next? Yeah, we can start querying the people graph. I just opened the Neo4j browser here. You should remember your password, and yeah, it will ask you for that. Okay, here is the Neo4j browser, and you can input Cypher here and run the Cypher to query the graph. Let me first check the schema. Okay, that looks like perfect. The same as we model in the data importer. Yeah, person mentioned in sentence, and sentence belongs to a chapter. Yeah, it's very simple. So what's next is let's start explore the graph. Let me show you. Okay, I will drag my queries from the notebook. Okay, here is a query. It will tell us who has the most mentioned times. Yeah, let me run. Yeah, you can say that a person name here and mentions count here. Yeah, Kong Ming is the most mentioned person in the level, and Cao Cao and Xuan De. Yeah, Cao Cao and Xuan De is the same person, so there should be many problems to about the data processing. Yeah, I will talk about that later. But you can say the person network here. Okay, the other question is on which chapter has the most persons there. Yeah, you can use this query and match start with a person node and mention it in sentence and in chapter. Okay, and we will count distinct person name. Yeah, let's run that. Yeah, I made a mistake about the data importer. The chapter order should be in fact that it's not a Boolean type. I will change it to integer because we have 120 chapters there, but it created for us specify a Boolean type. Okay. Yeah. If we can just run import directly, and the data importer will merge the data for us. Okay. Okay, let me check that. Maybe I need to remove the false data. Okay, I will remove the chapter data first. Okay. You can see there are 2 more extra chapters there. So I will run the import again. I hope it works correctly. Yeah, it should work. Yeah, you can say in the chapter 91, there are 141 persons there. And yeah, that's the chapter has the most persons. Yeah. So next question is, we can query a person and in which chapter, just show the path. Okay. Here's the person Cao Cao, and here's our sentences here, and the sentences are belongs to chapters. You can say Cao Cao is mentioned in many sentences and many chapters. Yeah, that's the really simple path here. Yeah, let me show you a more complex query here, and you should want to know that who is mentioned in most chapters. Yeah, we can start query like from the person node and mention in, and in chapter, this is a pattern, and we can come to the chapters here. So let's run it. Okay, you can also Cao Cao is mentioned in many chapters, like 86. You know, there are in the total there are 120 chapters. So yeah, that's a lot. Yeah. Here's a character about it's a word just like you and him. Yeah. So that's another work to do about the data extract process. Yeah. Okay. Now we don't have, as you can say from the data importer, we don't have people, we don't have relationships between people. So next, I will start create a relationship between them. You know, in Laravel, there are many sentences, and the sentences describe the interaction between characters. So we will follow that if if more than one people mentioned in a sentence, we think that they have some relationships, or we call interactions. So we will find people in a sentence and will create interacted with relationship between them. So here is a Cypher query to do that. Yeah, the most thing about it is connect the person IDs and create relationships between them. Yeah, first it will help us find who are in the same sentence. Yeah, so let's run that. Yeah, we'll wait a few seconds. Yeah, it said create the 21,000 relationships about the interactive. So that should be a very big graph. So now we have the people interaction network. You can run the DB schema again, and you can say person has interacted with relationships to itself. Yeah. So let's start explore more about the interactive with a relationship. Here's a query about how many interacted of a person. Yeah, let's find the most people. Okay, total again and commit again, and you can say they are very important in the level because they have the most interactions. And we can also query the interactive path, like we want to find the Taotao's interactive network. So let me do that. Okay, you can say where is. Okay, here is Cao Cao, and he has most interactions with these people. Yeah. Since we lost the labels in the circle. So let's see the name of the circle. Yeah, that's the most interactive network from the level. Okay, and we can also query the network about friends of friends, something like that. And here is a query from this person to this person, and they don't have directly relationships. So from the people network, let me find out how can they connect each other. Okay, it's a very big graph. And you can say, okay, let me find. Here is the node 2. Here is the node 1. You can say there are many possible paths between them. Okay, I think that's some interesting or very funny queries from the people graph. So let's do some exploring from the third tool called Neo4j Bloom. would like to create a new thing. Yeah, you can say there are 3 nodes: chapter, person, and sentence. So yeah, you can input queries in the input text in the input of the Bloom. Like you can select person and interacted with person, and you can browse the relationship. Okay, it's a very big graph here, but you can see some clustering there. From Bloom, you can very easily explore the much more bigger data size, but before we do that, I'd like to update a property about the data. So as you can see, we have the interacted with relationship, and we'd like to set a property on person node that specifies the interact count. Yeah, let's run this query. Okay. So from Bloom, you can configure the person node, and you can configure its size and color, and based on a property like interact count. So let's do that. Okay, maybe then we create the rule. Okay, we will refresh our perspective at first. Yeah, because there are new properties. Okay. Yeah, we have the properties. Let me reduce the amount of the graph in the scene. I have another query about the Bloom. You can specify your own query here, and yeah, here is some queries about the chapter 1 network. We can just put the interaction networks from chapter 1. So that should be a small size network. Okay, you can see there are 78 nodes in chapter 1. Let me configure the size again. Okay, refresh again. Interact count, right? Okay, we can have color here, and where is the size? Okay, let me make it much huge. So yeah, that's it. You can see in the big and the deep nodes are the most person here. Yeah, that's just from the chapter 1. So we can also add chapter 2 network here. I just run another query. Yeah, so you can say more nodes added to the scene. Okay, use Bloom. You can easily and very visualize about your data and your graph. Okay, that's the 3 Kinders people network. You can use them as a very starting project. So let's back to this slide. Yeah, that's the code and the graph. If you have any questions or suggestions, please put them into the chat. Yeah, so yeah, let's share one more thing about the hardest part of this graph building journey. You know, the novel is in traditional Chinese, and it's very hard to understand by human beings. So if we want to use that as a data source, the computer is much harder to understand the traditional Chinese. So I like to recommend to use NLP, natural language processing toolset to do that. And yeah, that's the hardest part. I think that's the hardest part about many data projects. So my suggestion is starting with sample data and smaller data to do that. And another suggestion is to use very easy tools to get started, like Neo4j DB and desktop and many other developer tools. Yeah, and you can find my code in this GitHub repo address. Yeah, thank you.
Super. Thank you. Thanks so much, Shiny. It was a great presentation. We have a lot of questions in the chat. Let me just take one by one. Okay. So Jay is asking, did you model after extracting raw text or after that? Before extracting the raw text or after that?
Yeah. Yeah, I put the raw text. Maybe I forgot the hardest part. I extracted the full level from the raw text. Yeah, so you can let me share my screen again. You can see. Yeah, you can see in my GitHub. And yeah, here is the raw text, and you can see there are 120 chapters. Let me click the first one. Yeah, here is the raw text. And the hardest part should be here. How to get the raw text or how to get the raw data. I know many people are using Python or Scrappy framework. Yeah, I'd like to recommend use APAC. Yeah, Neo4j APAC can do that very easily. With this Cypher query, you can pull down the whole novel from this website. Yeah. Yeah, that's a raw data. And the second one is how to extract sentences or words or person names. I use an NLP, the framework called ALTP from a university from China. Yeah, it supports Chinese very well. So you can see the Python code here to do that. Yeah.
Okay. The next question is by the same person. How many languages does Neo4j support. Is there a link that you can refer to?
Yeah, I'd like to say more than you think. You know, there are many ancient languages in China, and yeah, I'd like to share a community story with you. One day, a person reached out to us and told me how to extract a tongue character. I don't know how to pronounce that from the ancient novel like that. Yeah. Yeah, actually, I have that photo on Twitter. You can find that there. Yeah.
All right. Is there a link by any chance, Shiny, that you can share it with everyone?
I don't think we have a link about that, but you can find many like encoding tips from our documentation. Yeah.
Mm-hmm.
Yeah.
Okay, sounds good. And yeah, there are more questions coming up. So the next question is by Conrad Taylor. He asked, how does one get back to console window from data import window? Is there a link on the page or does need to enter the URL?
Yeah, like you can say I just click the 3 buttons there, and yeah, it will open 3 tabs for us. But if you use workspace, you can just easily switch the tab in the page. Yeah.
All right. And I think this is probably the last one.
Okay.
Farhan is curious to know how to provide battle or fight relationship between characters in this story.
Yeah, that's very funny. As you can, as you know, I just started exploring the ancient novel data set, and there are many examples show how to explore the relationship more than people interaction. Yeah. Yeah, I'd like to say, please check out my repo later. I will share more about that. Yeah.
All right, great. And I just shared the link of GitHub again,
Yeah.
broadcasted it for
Thank you.
everyone to make a note of it.
Yeah.
Thanks, Seema, as well, for sharing it across. Yeah, I think those are the questions that we have. It was a really exciting session. I learned a lot from the session
Yeah.
today.
Thank you.
Okay, perfect. Cool. Thank you so much, Shiny. I think we have more time to take up more questions. If you have more questions, you can just quickly share it in the chat window. We can take up a few more before we move on to the next session. We have time for the next session to start up. So maybe you can take a snack break if you want.
Yeah.
You can stay hydrated. Perfect. Thank you. Thanks so much, Shiny. I
Thank
think
you.
that's it. All right, folks, we'll be back shortly in next 10 minutes with the next session. Meanwhile, I'm just sharing the agenda for the day today. Let's enjoy some music meanwhile. All right, so we are almost there, and we would be starting our next session, which is a lightning talk by Vlad, who is a software engineering manager at Agora. And he's going to present something really, really exciting, which I am very fascinated about, GraphVille, a Neo4j educational platform. So let me just bring in Vlad onto the screen. Here we go. Hey,
Hi,
Vlad.
everyone. Hello.
Hi.
I hope you
Over
have
to
a
you.
good day today.
Yeah.
All right. So can we start it?
Yes. You're all
Awesome.
set to go.
Awesome. So let me just turn on the timer. I have a lot of slides and I have just 15 minutes for that. I hope it's going to be enough. Cool. So let's start today. Going to talking about the EdTech project. And welcome to my stage. This is it. We're going to talk about the GraphVille. It's a graph educational platform that recently been launched just in September this year. And before that, a few words about me. My name is Vlad. I'm a software engineering manager at Agoda. Agoda is one of the world leading online travel agencies, part of the Booking Holding. And we are hosted in Thailand, here stayed in the Bangkok, our headquarters for the tech teams. I'm already in around 13 years in web development. Originally, I'm from Belarus. And my journey with Neo4j, my learning started in 2019. So I have a bunch of projects that have been released, just open source projects. So one of them is Strash. It's a code knowledge graph and the tool to actually build it. As well, one of them is Barista. It's a small tool to generate the graph from the imports of your client-side project. And the last one is called GraphVille, and this is the topic for today. We're going to talk about this. And agenda is pretty much simple. So first, I'm going to cover idea, then we talk about the creation process, and we take a look on the result. All right, let's move on. Let's talk about the idea. So idea came to me in the early beginning of my journey with Neo4j when I just started learning it. So I started learning in May 2019, and I take it as a challenge. I decided, okay, guys, I will try to learn Neo4j every day, and every day of the months, in the whole months, every day, I will learn something and I will write a story about it. I will write a small short article about it. And this is how it came to this 1 month graph challenge. And I write 30 different articles on different topics that cover more or less my learning journey. And 2 stories out of it become a kind of like the basement for the GraphVille. So I was thinking about like, well, it sounds interesting. Something like I have a context, I have a basement for the education, and this is kind of a small town where people can solve their problems using graph. That's how it came to. And when I have this idea, then I build a deck of slides, and I decide to share it to Neo4j community manager. At that time, it was Karen Wallach, probably somebody know her. And I share it to her, I explain my idea. So let's travel in time back to the 2019 and take a look on that deck, take a look on that slides. So I call it very ambitious. I call it Neo4j educational platform. That actually like pretty much ambitious. So what is it about? First of all, EdTech projects, it's a mainstream nowadays. I think it's a mainstream like every day. So we have a lot of very, very famous known names. And some of them, what they do, like what they actually focus on, they challenge the people. They make the education fun, like the programming, learning the technologies, they make it fun. They make it challenging to the people. So I was thinking like, what exactly make the difference? How is it possible to build something similar like this? And I pick up some kind of base ideas from how it should look like, and I write it down, and it was kind of building my vision of what I plan to do. And at that time, in 2019, in Neo4j, we don't have much that much excited projects about the education. we have a Graph Academy at that time, just a bunch of videos without much interaction. So if you want interaction, if you want to really interact during your learning, you probably need to set up everything on your local machine, or maybe in some like host it online, and then move on with education. But the data behind it, you need to build it, the story behind it, problems behind it, it was quite challenging. So it's very depends on the person who is actually learning. So I was thinking to fix that, and I was asking, like, we have such a cool tool like Bloom, why your educational process not looks like Bloom? So it's going to be, this is your context, this is only thing that you see during your learning, and you're trying to explore it step by step, learning something cool stuff about Cypher, about Neo4j itself. And this is how I came to this kind of Graphville idea, that in Graphville, this is a small town, and you need to help citizens to solve their daily problems. And in that problems, you have kind of a storybook, and you pick up the story and trying to see what's going on and how you can help to solve the problems and questions. So this is one of the examples that I have that time. It was just pictures, like nothing behind it. It's just pictures, it's just idea, it's just explanation of the problem. And I was thinking about, like, okay, we need this online editor. We need this as something like a Bloom. Oh, this is it. This is Bloom. This is how it may looks like. So we have some story, some context, and you're moving on in this context, trying to write some query, execute it, and see, is it correct, not correct? And this is your learning. This is a summary of it. That was a presentation of 2019, which is just an idea. So this is it. This is how it was. This is what the idea is. And now let's back to nowadays and take a look where we are. Let's talk about the creation. So it was a long journey for me from the moment when I just created this idea and actually start working on it, because it's a free time. So I just create another one project, start building some stuff inside it, find people around me who can help me to build this stuff. And during this time, I also learned I have a certification, I become a feature community member, I start write articles. So all this project that I mentioned before, it was somewhere in the middle of this journey while I actually do the building the Graphville. So you see, it was like kind of a timeline with several checkpoints, how it was. And right now in September this year, it's actually officially launched, and I released the first lesson. So this is it. This is how it looks like right now. It's a bunch of the illustrations from the Graphville educational platform. So here you can find Neo4j courses, you learn Cypher, you see different topics. So right now in the season 1, I have 6 episodes. It's like about the pattern matching, about aggregation, about data type, about pathfinding, and other stuff. Now let's try to take a look on the creation of this online editor. This is the biggest challenging part here. So I was thinking, like, this is the only screen that the students see, and this is super important. This is what I draw just using the pencil in the like Google Docs. That was a prototype. Then I actually create something like a HTML mockup, how it's really going to be. And in the end, I build it, not just me, but with the help of other people. This is the final result. So what we have here, you see the page, what exactly every student see in the Graphville educational platform. So you see a card with a topic, you see some content, which is describing the learning process, maybe some theory, maybe some problem. You also can have a task or test that you need to pass. So here, for example, you need to adjust the Cypher query to execute it and actually find the answer on the question. If you don't know exactly how to do, you can use a hint. If you're correct, then it's going to be solved and count as a +1 more point to your total score. If you wrong, still you can just pass to the next chapter, pass to the next page, and just proceed with your learning. And back to this card again if you want. So here you can see the graph. Graph is very interesting part. So how we made it, like how it was built. So we have a choice, and the choice was like, maybe we can just find and use some existed library to build the most critical component of your project, or just create it by yourself. And definitely we select the second option. So we decided, yeah, we're going to build it. Why not? Why? Because it's fun. We will learn something new. We're going to build it in the way that we want. And we not really think that it was that complex problem. So this is a comparison between Bloom, Neo4j browser, and the result that we have in the GraphQL editor. We using D3.js as a library to build this graph. And this is a small demo right now, how it looks like. You can take a look here. So the bunch of functionality is like, you can zoom in, you can zoom out, you can drag and drop nodes, you can drag and drop like the whole graph. You can click on the node, see some pop-up with the properties inside. We should have the same stuff for the relationship, and we're working on this right now. It's not ready yet. And as well, you can notice that right now we have only one relationship between the nodes. So this is something like current limitation we have. And we're also working on this like to support the multi-relationships where you actually not overlap with the relationship, but you're going to see all of them together. So this is something that we plan to do. And this is actually part of our whole plan, and this is what we're actually thinking to do. And right now you can take a look on this by yourself. You can go to the www.graphql.com. You can read more insights about this process and about the result and how we go there in the Medium article. We have a GraphQL community that we currently just established, and we start building it. And what is really great, like, for example, we have a Twitter right now, and we have it, and it's real, and we have real people who are subscribing, who follow us. We have real people who pass the lessons, they pass the episodes, and they like it. And we also have like people who share the certification that they passed this kind of episodes. And we also have sponsors who are actually giving us the credits so we can draw more pictures, we can have better infrastructure for the platform. So this is actually happening. So from that 2019, that it was just an idea, just some slides shared to community, now it's become a real project, a real product, and people can really learn using it. So this is a fantastic, this is really that I'm excited about. And right now we have a team, we have people who are helping to make it live. We are working on this community. We have to have planned to publish new episodes, add more features, and draw new illustrations, and definitely attract more sponsors, because this is a pure indie project. We don't have any sponsorship, and we're really glad if you can help us to actually grow. So this is it. Welcome to GraphQL. Thank you very much for your time. I'm open for your questions.
Awesome. That was really amazing, Vlad. And I love all the illustrations and graphic, and so do the audience.
Thanks to Irina who drew all this. It's really beautiful. I also like it. Like when I saw it, I just fall in love with these pictures, and it's really helped us to move on with, like, you see, like you feel it. It's real. It's like now it's real. It's like not just something that you just thought about, but now it's real. You can touch it, you can feel it, you can see it, and it's tasty.
Awesome. And these are the Medium handles if you wish to get connected with Vlad and want to know more about his 1 month challenge.
Yeah. I would also want to say that if you want to try it out, we already released the second episode. If you put in a chart your GitHub name, your GitHub account name, I will grant you permissions to access to that beta version of the second episode, and you can try it out. Right now, you can try for free, like we have a public one. The first episode, if you want to try second, just put your name in the chat, and I will grant you access to that chapter.
Cool, interesting. And then there is a question from Michael. He's asking, what is the most difficult way to teach, visually, specifically?
The most difficult way to, I don't get the question. What is it? What's the
I think he's trying to understand, like, is it really difficult to teach visually Neo4j?
I think no, like I think this is the whole sense of graph, because you see, like, it is visually, it is conceptually nature of the people. So this is how we explain things to each other. We actually draw some pieces and connecting them with some arrows, with some relationships, and this is why it's so easy to learn Neo4j. This is why it's so excited to actually understand piece by piece how the things work, why the things connected, how the algorithms run on the graph, how you can optimize the graph, how the query, like how to write the query, how the Cypher is working. This is really kind of natural for persons. So this is how I personally see it. Like it was really easy, and I really think that every engineer need to try it out. Need to try graph database. It's something special.
All right, great. And then we can take it one last quick question. Is there any gamification in GraphWheel?
So about it is itself gamification. So the concept is based on the kind of Netflix stories, and you have a season that you read some story about some characters, and this the plot inside the story, inside the episode. There is a plot. There is some interesting things happen with the heroes. So you read about this, and you're trying to help them. And you go through this journey, and you unlock your achievements. Basically, you unlock every query. You just need to answer the questions, and then you got the total, which is like total score. That's all the gamification so far. But really, if you have some ideas, put it in our GitHub community repo, and we will try to create. We try to make it live. If your idea is awesome, we just build it.
Awesome. Thank you. Thanks so much, Vlad. And then there are more questions. Unfortunately, we can't take them up right now.
Yeah.
But I'll request if you can stay in for some more time in the chat and respond to the queries in the chat window.
Thank you. Thank you very much.
Thank you. Thanks again, Vlad. And then I want to bring back my friend Shiny, who is going to talk about how to learn Neo4j in Chinese with Neo4j Graph Academy.
Hi, Steve.
Hi. You're back
Good
again.
to see you again.
Yeah.
Yeah, I will give this talk in Chinese language. So
Sure.
I put a PowerPoint slide, and it can give live captions. So hope you can understand. Yeah. So if you have any questions, and please put them into the chat, and we will see that. So yeah, I will start my talk with Chinese language. OK。好的，接下来这个演讲的话，我会用中文来进行，然后我同时开了一个 PowerPoint 在这儿作为实时字幕，大家应该是能够看到字幕是英语的，我说的语言是中文。字幕会有一点慢，应该还可以。好，那我接下来的演讲呢是Learn Neo4j in Chinese and Japanese too with Neo4j Graph Academy。那我们知道，要学习一项技术的话，尤其是比较新或者说是自己不太熟悉的技术的话，除了看技术的文档和跟着老师的教程来学之外呢，我们更重要的一个是要有一个体系的结构，知道从哪里开始，然后知道我们要学的东西有它的组织结构是怎么样的，有哪些章节，有哪些组成的部分。那除此之外呢，还需要我们知道它一个学习的进展的一个情况，或者说是循序渐进的一个步骤。另外我们不可缺少的也是需要一些学习技术的话，需要进行一些动手的实验和真正的让自己的程序跑起来。那在这个过程中呢，其实 作为技术人啊，其实有很多的疑问，或者说遇到了很多样的问题。比如说我们要学一项技术，如果说它这个技术它需要的软件环境需要我们花很多的时间去配置，或者说需要一些很繁琐的设置之类，那我们就很难让它真正的跑起来。就相当于说我们还没有开始真正的学这个技术到底是什么样的，我们就花了很多的时间在配置啊和设置上面。就有一句中国话叫做从入门到放弃，对，这个还没有入门就可能导致了大家已经放弃了学习。那所以呢为了解决这些问题呢Neo4j有一个平台叫 Graph Academy。那在 Graph Academy 上面呢我们就可以按照不同的级别然后按照不同的学习路径，然后来选择自己要学的内容。那今天我要演示的是，大家可以从这里看到，我们除了英语之外呢，已经支持了中文和日语这两种语言，两种额外的语言。那我们点开中文这个课程。好，这是 Graph Academy 上面的中文课程。目前呢是有一门Neo4j基础知识，我们可以从这里浏览课程开始。那首先呢，你需要一个账号来登录到 Graph Academy， 然后就可以开始报名这个课程。那报名好了之后呢，就会进到一个Neo4j基础知识的这么一个课程的一个学习的界面。那这里面可以看到有一个课程的目录，它分了几个章节，然后里边每一小节的内容是什么都很清楚的列在这里。然后呢，在这里有一个模块的简介，然后我们可以看到这个模块会介绍什么样的内容，我们点击下一步就可以开始它后续的学习。好，我们知道以图的方式去思考叫 graph thinking， 我们是从七桥问题这一个很有名的数学问题开始，然后这里呢也是做了一些介绍。我们可以看到从中文的介绍里面呢，就我们可以很熟悉的很快速的开始这个学习的过程。那除了 Graph Academy 除了本地语言之外呢，它本身课程的结构呢还会设置到一些知识检查。如果你这一节的内容学完之后呢，我们可以通过这个知识检查来看我们是不是理解和掌握了本小节的内容。好，我们这里是谁发明的图论，我们选这个，然后我们可以点击检查结果，然后它这里会出来一个答案。如果答案正确的话呢，我们就可以进入到下一节的学习。好，在这一节里面呢，我们可以看到更多的关于图的基础内容，比如说节点和关系。那这里面呢也是可以点击这些选项来回答这个问题。比如说这是节点还是关系，假设我们想在图中添加额外的数据来说明 Michael 住在伦敦，哪个元素最能代表它？这个我们来选择一个。好，这里回答错了的话，它会有这么一个提示，那我们可以再重试就可以。好，那我们可以接下来继续我们的整个的学习过程，在 Graph Academy 都是非常方便。那除了这样子的学习和我看一下，除了这样的学习和检查我们学知识的问答之外呢，其实在 Graph Academy 课程里面呢，有一些需要写代码的地方。我看一下有没有这个课程里面有没有，看一下。好，这个课程里面是可能是没有那个沙箱环境的。那其他课程的话我们后续也会推出更多的中文课程，然后里面需要写代码的，大家可以直接在这个界面里面，然后把Neo4j browser打开，然后就在里面可以写 Cypher 的查询。好，我们可以在这里选不同的章节，然后来跳过来看。好，这是这个课程的基本 内容学完之后呢，可能会引导你进入到下一步的学习。在这个里面，第一个图里面就是我们经典的电影数据集。那很多地方在创建 Neo4j 数据库的时候，都可以选这个 movie dataset 来作为默认的数据集加载到这个数据库里面。那这一节里面呢，也是介绍了这一个数据集。比如说有这个数据集的节点包含38个 movie 节点，就是电影的节点，包含133个 person 的节点，人物的节点。那这些属性在这里都有详细的介绍。然后关系的话是有这几个关系。好，那这个课程学完之后呢，我们就可以回到 Graph Academy。好，然后就看你的课程列表。那因为中文的课程目前还比较少，那我可以演示一下需要有沙箱的那个环境。比如说这个课程里面会有。好，那在后续我们会陆续推出其他的中文课程，比如说，我看一下，从这个开始过后呢，应该是 Cypher 基础知识。这里 Cypher 基础知识我们正在翻译当中，然后陆续后续会推出这个课程。那除此之外呢，其实在Graph Academy 的话，你学习了一个系列的课程，比如说Learning Path 里面这些开发和那个Cypher 这些之外呢，你可以考那个认证。我们 Neo4j 现在提供2种认证，一个是Neo4j Certified Professional 认证专家，另外一个是 Neo4j GDS 认证的考试。那这2个考试的话，其实是它里面包含了一系列的课程，就是你需要掌握。这儿可以看到你需要掌握这一些Neo4j基础知识Cypher 基础知识，然后图数据建模的基础知识，然后CSV 数据导入，然后还有高级一点的 Cypher 查询。那这样子的话，你就可以学完这些课程之后呢，你可以来尝试一下考一下这个认证。目前这个认证呢，提供了非常全面的关于 Neo4j 的基础知识。然后考这个认证过后呢，你可以添加到自己的 LinkedIn 界面上，对，然后你的其他的伙伴就可以看到，有一个 Neo4j 认证的 badge。好，那大家有问题的话可以发在聊天区，然后我们会看到。OK。Okay, that's the brief introduction of the Chinese language resources on Graph Academy. Yeah, you can also check out the Japanese courses there. There are 4 courses are translated into Japanese. Yeah. Okay, that's it.
Awesome. Thank you. Thanks so much, Shiny. This session was specifically in Chinese for the Chinese audience. And nonetheless, Graph Academy is also available in English and in Japanese language. And I think there are a few more languages, right, Shiny?
Yeah. We are planning to do that.
Yeah, I think Graph Academy is also in Spanish, if I'm not wrong. But right, this was specifically for the Chinese audience. Thanks so much. Well, the track was named as Learn Neo4j in Chinese with Neo4j Graph Academy, so it has to be in Chinese.
Yeah, thank you.
Thank you. Thanks so much. All right, so we are almost there, done with this session, and we are next. This next session coming up with Adrian. We have some more time before Adrian comes on stage, so let's take a quick snack break meanwhile. All right, it's time to bring in the next speaker on the stage. I have with me is Andrian. Andrian is division manager at OPT New Caledonia. I'm not pronouncing it right, wrong. And he's going to talk about from Game of Thrones to information system cartography. Well, that's an interesting topic. Over to you, Adrian.
Yes, I guess. I hope. I hope you enjoy the storytelling. So
I am enjoying a lot. Looking forward to your session now.
So just let me know when I have to start up.
You can start now. You can share
Okay.
your screen.
So let's go. Here we go.
You're yet to get your screen up. Have you shared your screen?
Yep. Currently shared.
I didn't get any prompt to.
I can reshare it.
Yeah, that would be helpful. Sorry, folks, for the technical glitch. Make sure you are stretching your legs.
Reshared.
Nope, nothing yet. Oh yes, I've got it now.
Okay. Okay.
Perfect.
So now
Cool.
resharing.
I'll let you do the talking and sit back and enjoy the session. Thank you so much.
Okay. Okay, let's go. So in my session, I'll talk you about a full storytelling from the very beginning, which occurred many years ago, to enterprise KPI and performance. So the very few years ago, maybe at least 4 years ago, I discovered on Twitter storytelling about Game of Thrones. The TV show was everywhere. People were talking about Game of Thrones at the coffee pause. And I discovered this really amazing data storytelling. And I really wanted to achieve this kind of things. I was really wondered, and I wanted to be able to produce that kind of things just for fun. So in New Caledonia, there is a comic book, and I decided to implement it the same way Game of Thrones and see what could happen. So it's a paper book. So I had to modelize the data. I took inspiration from the Game of Thrones storytelling, started to modelize characters and interaction between characters. Then I had to collect data, which was a manual process, switching pages and putting the data in my fingers on my laptop. Then prepare the data in CSV, actually. Then starting to perform some analysis. Then produce storytelling, discovering models. And while pushing some analysis, at this time on Gephi, I started to see emerge like kind of intelligence. In fact, this time it was about sociology. And this is a very important part in this adventure because it led to a lot of other researches. To make short, here the data says that kids talk between kids on the bottom on the left, and on the right side there only are adults. So that was my very first discovery, and I wanted to perform some other kind of discoveries because I really enjoyed the feelings. 3 years ago, when I came at OPT New Caledonia, I'm in a division where we have a lot of data coming from a lot of places, a lot of applications, a lot of workflows interacting each others. And some people in my division started to draw with a mark on paper this kind of drawings you see on the right. It's the original one, in fact. And people were coming in the office and asking us, would you know which connects to this and do that? And I decided to pay great attention to this kind of drawing and even perform some experimentations, which were taking back the paper and see what people were doing. And people did strange things. They started to ask, where is my paper? Who took my paper? I want it back. So that was very interesting as a manager. And I started the following workflow, which is still in use today. I started to use my team activities, then started to implement visual management, which is a key part in graph databases, then starting to challenge with question. Not only once why, but why, and finally you get the final answer. You get the real problem you have to solve. Then when you have a quite important amount of questions, you have to sort them and score them. The most important one or the easiest one, you have to achieve this kind of management task, which can be led with the Lean method or Agile Scrum methods. And then when you answer this question, you have this catalog of questions, you see new opportunities coming to you at a very fast pace and not necessarily at a very high cost. So here is the framework I use on a daily basis. First thing, we deliver software very fast and the right thing. So if we fail fast, with not a lot of loss of money nor time. Then we produce as a team. It's very important, even with people with remote working, we produce as a team and we use the right tool for that. Then, as developers, as software developers, we make a version of everything. We can go back in the past at any date we want. And then we deliver. We deliver at a very fast pace, very often, and we check the quality and we challenge how people react to what we are delivering. We answer questions. We are here to answer questions. And then, this is a bit more the management part. You observe new habits. Because when people have new tools of new answers to their traditional questions, they change their habits. And you have to take great care of that. Then, if you are a lucky guy, you can see appropriation, which means you are on this track to success. People use your tool and sometimes use your tool to make something else that you initially thought about. This is a great indicator of you are on the success. And deliver value at a regular pace, which means we don't stay a month without delivering something. We deliver value on little increments, weekly or sometimes daily. And finally, this is the holy grail. You impact the culture. This is really what you must achieve if you want to perform with many people. So there is a little question for you. So I'm going to launch it now. According to you, which KPI drive your IT services? So if you go on menti.com and put your code, you should see which KPI are coming up. If you can go to it. I don't know if you can use it. I don't see people coming. I'm going to copy the link in the chat. Here we go. Oh, maybe the technical issue. So maybe you could think about financial, people, where do you live, these kind of things. And so I skip to our tools, or stack, like we say in software development. First, we use paper and markers. For visual management, it's the best tools. Everyone can get this kind of tools. Then we use GitHub, github.com, to store the data, to make issues, to store our code and our data. Then comes Neo4j, then Bloom, Neo-Dash, and then more technical, Docker, Cypher, Python, Jupyter Notebooks, and G5. Ah, yes, the first results are coming. Excellent. So this is actually very interesting. So I see coming on the first KPI, human, money, time, security, return on investment, and time. This is really an awesome feedback, and we'll see later. Time, yes, financial, achieved goals, ticket resolution time. Oh, it looks good. New versus closed tickets. Yes, this is all about performances. People, human are coming twice. This is really exciting. The main philosophy of my speech is that we have to achieve, to see the enterprise as a whole thing. And that, like in nature, the whole is greater than the sum of its parts. And it's like a mantra, an everyday mantra, which help keep us on the track. If you have things in pieces, you will lose performances, you will lose money, you won't be able to deliver the solutions you want to deliver at the right pace. So here's like a Maslow pyramid, made by my one. So first, like a lot of you have already said in the Menti, there is a money. Without money, you can't have people working for you. This is why people and skills come just after the money. If you have people with no money, they won't work for you except on open source, but you won't necessarily be able to achieve the goals you have to achieve. Then once you have money and people, you can develop your own services, which mean website, applications, mobile apps, that kind of things. We are software engineering, and then we are coding a lot of things every day faster, and then we generate technical debt, which means it works one day, but 2 years later, the look and feel is not the right one. We have security flow eventually, and that kind of things. And then we come to the next step, the build and run. The build and run, for those who don't know what it is, when you build things, everyone loves to build things. I create something, I'm very happy with my new toy, but then 1 year later, it can become a real hassle to maintain it up and running and secured. And then we achieve the top of the pyramid, which is the time to market. When you have an idea, you want it to get it on the next week, on the next month, and also next year, because if you deliver on the next year, other people will have made instead of you, and you have lost. And then you are lack of money, then you will lose people, you won't be able to run your services, and this is a very bad trip. So this is a holism. And the holism relies in IT management on a lot of data. We are data-centric, we are data-driven. So here on where we get all our data, I will show you in the next slide. First, our assets are applications. Applications are web services, mobile apps, software as a service, everything we rely on to manage our activities. Then, as an other service, we have github.com. I mean the API, because GitHub gives a lot of API to see what kind of code are we doing, how many people push code, when, which kind of quality, that kind of stack. How we using Java, Python, this kind of things are provided by API. We can do the same kind of things on GitLab, which we are doing. Then we can use SonarQube for software quality. And you can see we have actually a lot of API of data sources, like sometimes end of life, because each piece of software has an end of life, and you have to manage it. You have to monitor it if you don't want to have problems. Also, we have some enterprise resources like Active Directory, which is linked to people. You want to know who is working for you. Also, skills and missions. Where are your skills? Where are the competencies? Do you have the right people at the right place? And also, you can integrate with a lot of third-party services like open data, localities, geographical information systems. financial services on Oracle, for example, or even scrap documents on SharePoint. There are other kind of data, but this is what we can work on. Then the next step is to map all the organization as the whole thing, as a whole living thing, driven by the data itself. So here is how we can browse the data model of enterprises. This is graphical. And you can see that how things are interacting the one with the others. Then you can see that later you can drill down, see how people are connected to financial services, how technical debt can be managed, and that kind of things. As a manager, when you see that kind of things, I can tell you that it's a very exciting experience because you feel that finally you master your data. Then you can rely on graph data science, which is embedded. I won't make a full tutorial on which metrics we can rely on, but mainly you will see how we use centrality, for example, and connectivity and that kind of things with visual management. Here we go. Our first topic is application centrality. So as you can see, there is an application in the center, and what the recurrent question we have: if I fail this, if I have issues on this application, which other application will fall? This is a crucial question, and we have to be answered to answer it very fast and very, very, very efficiently. That was our first MVP on this modelization. Now it's time for the second test. I'll send you the Menti. Here we go. Let's go. So you have to sort application criticality by domain. So is it the money? Are there the people? Is it geographic information system or document management, like invoices, that kind of things? Or the fact to know your customer. So once you get some data, some IDs, and once you have finished your ranking, we'll see if the data is matching your expectations. I make a little solution to keep in time, to keep in track. So first, very interesting. Financial is coming first, then the customers, then human resources. Human resource is coming second, then customer, then document. Very interesting. So this is what you imagine. And what you see right now on the presentation is what we got out of the data we currently have. So this is based on the calculus of centrality on an algorithm called PageRank. And the first kind of software which is coming first is money, is a financial capital, because without financial capital, you can do anything, but this is told by the data itself. Then you have a second kind of capital, which you have ranked third, but which comes second in our data. It's a social capital. It's the people, it's the skills, that kind of things. And then the surprise came that for the third position came the GIS. And for telecommunication and postal services, finally, it makes sense. Then come customer and prospects, which are linked to financial capital, then document management. This is very exciting and very satisfying to see that you can modelize and that the data bring you some kind of truth. Then often in presentation, in some meetings, people make a lot of video and you have picture. But in information services, what you want is data. So a drawing is good, but our job is to provide data. So this is how we achieved our modelization. And on the right side, you have a cloud environment running on Azure. with power-ups and that kind of things. And on the left side, on the yellow, it's the on-premise. Items on the right side on blue are blue because we have an attribute telling that it's a SaaS services. And what we can say with data is that you have a single point of failure here. You have to pay great attention to this link, because if you lose it, you lose all the right part of the application, and then you have a loss of services. So it means you have to put efforts in putting high availability services on this side, driven by the data. This is what is really exciting. Then I also talk to you about people, skills, mission, activities. So what we have achieved is that we could import through API calls referential of skills, which is called SIGREF in France, is dedicated to information services skills. And we could import them on our model. So here I am. I know that I am managed by some people, but for each people of my team, I also see which skills they have. So you have a cartography and also a family of skills. For example, here I see that we have a lot of skills around project management. So I can make decisions. I can ask for more resources, for example, to manage project, or more resources for software developer if I need to go faster. Then we can use what we call topology. Topology is a mathematical concept, which is in fact the science, the study of the space. But here, very simply, what we can see on the left is that topology, which is an abstract concept, becomes a really important, very important KPI. On the left side, you can see that you have two kinds of knowledges. You have two graphs that are disconnected. This is a lack of knowledge. Clearly, you have two systems, and you cannot connect them. So you lose information. This is not holism. On the right side, this is what we could achieve after some work on scrapping new kind of data, and then we could build a bridge between these two graphs. And then it means that we can generate more intelligence, more knowledge on each kind of node of the enterprise, from people to assets, to money, to everything you want to know. You can discover a lot of very exciting things and put some KPI. For example, for those who know DevOps, DevOps is how operational sysadmins, DBAs, are collaborating with software developers. And here, thanks to the data we've pulled from GitHub API, you can see that there are some codes exchanged between two kinds of teams. This is all generated by data. In fact, this is sysadmins here and their repos all around. This is software developers and their repos. And you can see that some people have made contribution each other. So these two nodes is not that bad. We can make DevOps between these two entities, but not with this one. Why is that? Should we improve that? Is it a risk? You have to make choices, and with that, you can perform this kind of analysis. And if someone tells you in your organization, are you doing DevOps? You can yes, but I have two islands, two disconnected graphs. Centrality of applications. Sometimes you can see that you have clusters of domain-driven clusters of applications, and sometimes you have an application which is between these two domains. So this means you have to put a lot of efforts to make this availability as big as possible. Then put maintenance resources and a lot of people to make sure this stays up as much as possible. As told earlier, when you develop things also, it's like your car, you have to make some maintenance. And we could inject some data about software end of life, which means past a certain date, you have to change your software, because if you have a security flaw, it won't be fixed. So you are in danger potentially. So we could create this Neo4j dashboard. We can make available at a single place all the technical depths KPIs. So you can share it with other teams and be able to invest on the right place Sometimes technical depth may be acceptable in some places. Maybe JavaBit is not so bad, but in some other places, you have to fix Angular because it's end of life and it won't be secured, or it won't be able to offer an optimal experience, user experience. So very easily, as we can get the whole thing, you can attach technical depth to financials. So this is really exciting. And even you can find path between technical depth and financial cost. For example, do application with the maximum technical depth imply maximal cost? Where should you invest your money to avoid that kind of anti-patterns? And as you can see, it's as a service. You can see all metadata occurring when you drag a node, and it's very comfortable. You don't have to make to produce documentations, as it's very easy to use. So this is a little focus. So it's all Cypher driven. So here you have the query. You have a radar chart here from Neo4j. And you can browse interactively. Also, it's very comfortable in technical depth and apps. So you can find detect some kind of segmentation by domain, by stack, and that kind of thing. For software engineers, it's very comfortable. As told before, you have to be able to link applications to financial cost. This has been achieved. Here on the node, you can see the application, which has here a GitLab repository. So here is the source code. And you have a Node.js node. So you can see if you have technical depth. You can see who maintains your application. Eventually, you can also have a repository on GitHub. And this is the financial part. So this means the application, you have money to maintain this application. And how much did it cost to you? Each time you cost, you have nodes that tell you how much money you have put in. This is very easy to interact with, and the query as a model is very easy to use. Cypher queries are also very easy to design. So sometimes we change the paradigm and there are new metaphors coming out. So first, the questions are repackaged as data storytelling, which means when you have a large question, you will create a storytelling with maybe dedicated dashboards. We use the Bloom perspective to answer a specific question because they are very easy to implement and deliver. Also, we deliver domain-driven dashboards, which means, for example, for banking services or postal services or for technical depth. Each question adds a kind of perspective. Also, our cartography is version itself. Everything is done on GitHub, so on Git, and we are implementing semantic release, so we can go back and forth and compare things in time. This is a whole story. We're working on this project since more than a year, and here's the movie of the code we have created with bots. Here we go. It's a bit lagging. Okay. So you can see on the top left that we have a lot of CSV. Then at a time, Python scripts are coming because we started to implement a lot of things with some markdown here. So you see growing the number of Python files and CSV files. You can see some Cypher coming and Jupyter notebooks also coming because the data scientist has joined our team recently. This is the whole story of our database. One of the most great achievements I could see as a manager was the rise of skills and cohesion. And the fun fact is that, in fact, you can score that because skills are part of the cartography itself. So we have a data engineering. We are using Kafka a lot. and we are using a lot of third-party API. We are performing integrations with the thanks of Python. We have now data scientists who make reporting, analysis, and give us feedbacks, for example, on model qualities. And we have developed also data storyteller skills on Jupyter, Bloom, a lot of Bloom, Neo4j, and a bit graphics. And now we are working on generating machine learning models to make links prediction, especially on technical depth and money. At the end, one of the biggest success is to see that we could, we could impact the culture, as we could embed cartography right inside in documentation, like here in this example, Atlassian Confluence. I was not aware it was done, then I felt on that, so people are using it in real life without necessarily telling you they use it, which is awesome. What are the great questions, the biggest questions that matter? One of them is, how did application centrality evolve in time? Sometimes you have little third-party projects that appear, and 2 years later, it becomes very central and business critic. Thanks to Git and Neo4j, we can see how this application centrality is moving. At the beginning, it was peripheral, but then 2 years later, it's the center of the graph. So this is centrality. It's a very important metric. Then domain-driven clusters, is postal activities linked to telecom activities, for example? How do they? Let's find out. Also, relation between departments. Are people really collaborating code or not, or between applications? Is contribution between source codes linked to relation between applications? If not, maybe is it a risk? Maybe is it an anti-pattern? You have the data, you can make the choice, you can make the reporting. And some very easy metrics, very easy, but impacting ones. High availability fibers. If you have high availability applications and that you have apps that rely on it that are not high availability ones, you are at risk. So you have to make, so every HA app rely on an HA app. Personal data fibers and GDPR. So it means you have somewhere an application that has a lot of personal data, and you have another application that connects to the application, but which says, no, I'm not using application personal data. Is it really true? If not, why is this connection? You should pay attention and look further what's with that. And then the holy grail also, money, prediction between technical depth and financial cost. I mean variability. That's it. So the interesting part, the fun conclusion of that is that at first we are just here to answer questions to which am I connecting to? We are looking for answers at first, but now we are looking for the best questions, the best challenging questions. And that's my last slide. So if you have a question, you're welcome.
Awesome. Thanks so much, Adrian. Well, we do have a couple of questions in the chat window. Let me just take them one by one. The first question is there any algorithm used in this project?
We used page ranking, eigenvectors, and also the one linked to topology with how detect linked nodes, the one with others. So basically, it's a GDS package, and also a lot of APAC too, because we needed to parse text and perform transformation and that kind of things.
All right. The next one is it flexible for large data if using a graph model?
Actually, yes. It's designed with, and we have started to use indexes, because when you create relations at a certain stage, you need to put indexes first to ensure that you have unique nodes, for example. And then when you create new relationships, it can take a lot of time to create the relations itself. But for that part, it's like on relational databases.
All right. And the next one is, how do we access graph databases in C++ programs?
Oh, I guess there are a lot of SDK for Neo4j. We are using the Python binding, the Java binding also, it's very cool. I think there is a Go binding, I guess.
Yeah.
But the community is really active, so it's very well documented. And also you can perform REST queries or GraphQL, which we are not yet using, not yet.
All right. I think that's pretty much about it from the Q&A section on the chat window. Well, this was a really exciting session for me, at least. I'm sure it would have been same for the audience as well. Thank you so much, Adrian, once again. Thank you for your time, and look forward to having you for the next year as well.
Have a great end of day. Thank you.
Bye. Thank you.
Bye.
Bye. All right, so we are done with 7 exciting sessions, including the keynote, and then there's 8 more to go. And then we have the most awaited Q&A with Emil and Andrea. So make sure that you're putting in questions in the Ask Emil section on the Hopin platform for Emil to answer during his Q&A session. Meanwhile, stay tuned. We have a couple of more minutes left before we bring in the next speaker on stage. So just get up, stretch your legs, stay hydrated, get some water, get some snacks if you want, and then you'll continue back again. Let's enjoy some music meanwhile. Let me see what works good. Looks good. All right, see you soon. All right, so sorry for the delay, folks. We are back with the next talk. The next speaker is Koji, who you might have heard in the intermediate track as well. Koji is also one of our Neo4j Ninja, and as well as he's the CTO at UTI Incorporations. So Koji is going to talk about coffee knowledge graph today. Thanks, Koji, for joining in. I think you're on mute. You might have to unmute yourself.
Okay.
Awesome.
Sorry, too late.
No worries. Let's get started.
Okay. Okay. Can I? Okay, share my screen.
Sure. While Koji is sharing a screen, just a reminder, folks, make sure you put your questions in the Ask ML section for ML, our co-founder and CEO, to answer it towards the end. Okay, I think Koji, you're up and ready. Good to go.
Okay. Okay. Let's get started. Sorry for late. My title is Coffee Knowledge Graph. So really small slides, but I want to show about to Neo4j coffee graph. Okay. Okay. Oh, who am I? I love coffee. I passed 3 coffee exam. One is UCC Coffee Professional. Second, SAJ Coffee Master. Third, JCQA Certified Associate Instructor in Coffee. And also Neo4j Ninja. Okay. Okay, today's goal is know more about coffee and how to create knowledge graph. And let's make a knowledge graph about coffee. Oh, this is my house, my room. Okay, I have a coffee tree, coffee in Japan. Okay, coffee is a genius flowering plants in the family of Rubiaceae. Rubiaceae? I don't know well. It's small white flower and green becomes red beans. This is my room. Okay, what to do with coffee? Do you like coffee? I like coffee I drink coffee every day. 3 or 4 or 5 times. And when I go to foreign country, and I love to drink coffee in the countries. So New York and Asia and Australia. Okay, coffee beans. I don't like coffee beans I have had before, but some brands I don't like the smell. I don't like. How do I buy my next bean? This is a my question. it's better to buy a good coffee shop or mail order, supermarket. Currently, I bought coffee beans from foreign countries because I'm looking for. I love light roast coffee. So very few light roast coffee in Japan. So I order Finland, and every month I bought coffee beans. Oh, do you know the coffee grades? Q grade, Specialty Coffee Association of America, SAA. Q grade very famous, and COE, Cup of Excellence, is also famous. It's in coffee is little bit expensive drink, but it's good. I love to drink coffee. So, okay, my goal or question is how do I make recommendation by Neo4j. So I drink a lot of coffee, so data from what I have drunk a lot of coffee, okay, and I'm looking for next good coffee. So I think variety is the most important to drink to the taste. I think first time. So some variety is I love to drink. Ethiopia or Kenya, I love to. But some drink Costa Rica, I don't want like a little smells of Costa Rica. So I maybe different varieties have different taste. Yeah, and okay, Panama geisha. Do you know the Panama coffee beans? This is the most famous in coffee beans in Japan. 100 gram for 1,000 yen. It's very expensive, but it's good. I love to drink. So I drank geisha from Panama or from Costa Rica or from other countries. Beans is the same and the roast is the same, but so a different taste, I think. From Costa Rica geisha is like a Costa Rica taste, smell or taste, or like okay, I installed in the varieties in Neo4j. Roots is Rubiacea. I don't know. And roots 3 core beans. One is Liberica. Next is most famous Arabica, and third is Canephora. Maybe famous in Arabica is very, very famous, and the next is Canephora. Very few Liberica, I think. So let's show my screen. So wait a minute. Okay.
All right, Koji, are you done?
Yeah. No. I share my screen.
Okay, sure.
Yeah. Okay. This is a screen of Neo4j browser. Okay. And the roots. Yeah, this is a roots beans here. Has Liberica and Arabica, Cauliflower beans. Okay. And this is the history of the beans history. Yeah. Okay, this is Arabica beans. So famous beans, Ethiopia is here. Bourbon is here. Okay. Okay, next America here. Okay. Little dark one, dark tree nodes is a most important beans. Okay, and this is from Arabica and Liberica. It's 288 and 795 here. Oh. Okay, and okay, pause. So long one. Okay, this is okay. This is roots and three beans. and lot of beans here. Okay, this is bourbon here, yellow bourbon here, and this is Kona coffee, and this is geisha here. Ethiopia beans is here. Okay, this graph is not simple. 2 or 3 or more beans affect next beans. Okay, this is El Salvador Kenya types. I love here. So I try to drink two different beans of coffee, but these two different coffee is from same beans. One is Mexico. I like Mexican coffee. One is Costa Rica. So a little bit different taste. So I don't like smell of coffee. Yeah. Okay, like for example, and I drink coffee like a yellow one, or this one. But one is I love to drink, but one is I don't like the coffee smell, the taste. So this is just beans relationship history. It's not enough to coffee knowledge, I think. So coffee. So I try to another knowledge here. Coffee brewed by something. I love pour over. What do you like? French press or something? Made with coffee beans. Then I chose roast type, light, medium, dark. Yeah, and water. Water. This is the temperature of water. 95 or 203. Okay, and this is a water type, soft water type or hard water type. Most of Europe water is a hard water. In Japan, soft water. Okay. I add this coffee knowledge into beans knowledge graph, and I found the reason of I recommend. So I found the bean the next recommend that just not. I love water soft, and temperature is very important. 95 is a little bit hot, so I love 80 something, and I like prober, but sometimes French press. So next recommend is next recommend coffee beans and brewed something or roast is light. I love light, and a little bit down the temperature of soft, and coffee prober or French press or nail drip. And this is a drink knowledge. One of knowledge graph. So coffee is a drink, or some juice is a drink. This is a knowledge. So I want to try to enter the data into my Neo4j. So, but I can't now. Sorry. So, and wait a minute. And wait a minute. Okay. You see my window, okay? And this is what coffee tasting graph. Oops. Okay, you will see how to describe the fruity or berry or dry fruits or other fruits, or and sweet aromatics or sweet something. This is a word of coffee taste, and I create the graph of this coffee taste graph, word. So I can select the taste from taste to my from taste to my favorite coffee beans. Okay. Okay, this is so important with okay. Okay. This is the end of my session. So, do you have any questions? Please write the comment into chat.
Yeah, I think there is a question which has already been answered. Okay. Cool. I think there are no questions as such, but I really enjoyed the session. Trust me, Koji.
Oh, thank you.
I'm a coffee person, like a heavy coffee
Oh,
addict, but I've
your
never
coffee.
seen something like this.
Oh,
You're
where
you're
do you
truly
live?
you're truly a pro in coffee. Trust me.
Yeah. Oh, good. Out of Singapore, coffee. I love too.
Great, great.
Thank you very much.
Let's see if we have any more questions. Okay, I think there's one question. Can you join the different graphs?
Different graphs.
Yeah. I think
Uh,
the question is
you mean
reference to the graph that you had just created. If I'm guessing that.
another graph?
Or maybe I can ask Devjyoti to expand a bit on the question.
Oh, can you share your screen?
No, it's coming in the chat window. I have asked
Okay.
Devjyoti to expand on the question, if possible. The next question is by Philip. What do you consider good practices in the modeling process?
Modeling process. Yeah. Tasting graph. Yeah. The coffee beans graph is one of the graph. It's not good for me. So that coffee graph and tasting graph, and I want to temperature or water graph. I think. Yeah, making graph is really important. Try creating model. BIM.
And BIM.
What's a BIM?
I'm not sure.
Drink or food? Oh, temperature graph. Oh, yeah.
So I think what Devjit is asking is like, let's say you have a coffee graph, you have a testing graph, you have making graph, you have temperature graph. How do you combine all these graphs together, join these graphs together, and then make sense out of that one?
Yeah. Next time I will try. Yeah,
all right.
it's really important.
That's great. That's great.
Yeah.
And Philip is trying to understand, like, how to create a model applied to engineering and building information modeling. Do you have any thoughts on that? Any advices? Any idea?
Any ideas? I don't know. BIM? I don't know. Building information model. Yeah. I think really important flowchart, like flowchart building. Yeah.
Yeah, cool. I think this is a little off topic, and probably you can take this up in the chat window later on, Koji.
Yeah. Okay.
Thank you once again for a really informative session. We all really enjoyed your coffee experimentation. Look forward to you having in the next year as well, with maybe combining the coffee graph, tasting graph, making graph, and temperature graph, all the graphs together, and then making sense out of it.
Yeah. Thank you.
Awesome.
Yeah.
Thank you. Thanks so much. All right, folks. So we are done with one more session, and then we have next session coming up. But there's some time before we jump on to the next one. So why don't you sit back, relax, stretch your legs, get some water, get some food, and then we'll be back shortly. All right, so it's time for us to bring our next speaker on the stage. We have Mananai with us. Mananai is software developer and data science enthusiast, and Mananai is going to talk about analyzing spammers in Twitter user network. Twitter is in the buzz of late, so let's see what we have from Mananai today. Hi, Mananai, can you hear me?
Yes, I can hear you. You can hear me?
Yes, I can hear you perfectly fine.
Okay.
Would you like to share in your screen?
Okay, yeah, I would like to share my screen. Do we start right now or not yet? I saw it's like in 4 minutes 30 seconds, right? Not start yet.
No, I think we can start with your session. We're on time.
Okay. Let me share my screen. Do you see my screen?
Yes, I'm able to see your screen.
Okay.
All right. You can take it forward from here. Would you mind switching to a full screen version if possible?
Let me try. Okay.
Yeah, this is better. Thank you. Over to you.
Thank you.
You're live, Mananai. You can get started once you're comfortable. Can you hear me, Mananai?
Yes, I can hear you.
Okay. So just to let you know, you're live and you can get started once you're ready.
Okay, I can start now.
Yeah, you can start now.
Okay. Hi, everyone. My name is Mananai Sangsuwan. I'm a software developer from Bangkok, Thailand. I'm here to present you the topic of analyzing spam mails in Twitter user network. The motivation are the following. First of all, spams irritate user. When Twitter users see spam, they often not pleased with the spam. So normally they don't want to see the spam. So if we could identify spammers, we could block those accounts and we could get rid of all the spams. And the third reason is that it's a good ML and network analysis exercise anyway. There are 4 steps to do the analysis. First of all is to collect Twitter data. The second step is to implement a spam classifier so that the computer software can know which tweet is a spam, which is not a spam. The third step is to import all the data that we have collected to the graph database, which is the Neo4j database. And the last step is to analyze the data. The second, the third, and the fourth step would be done in Python notebook, which I will show you later. The first step is to collect the Twitter data from the real Twitter network. There are already a few resources that cover this topic, so I list you the information that you can take a look. The first one is from a book, and the second one and the third one are from my articles in the Towards Data Science. I will talk a little bit about how I did collect the Twitter data. The first step is to identify 50 popular trends or hashtags in the Twitter network at the moment. And for each trend, we would search for the tweet of that keyword. And the third step is that for each tweet, we identify who writes or retweet it. So we get the user from the tweet for each tweet. And the last one is to identify all the friends of the user who who wrote or retweet. The data that we collect from Twitter the first one is the status, which we call status in Twitter API, but normally people call tweet. The second one is the user object that wrote or retweet. And the third one is the user and friend relationship. Next, we will need to label the status, that whether each status is a spam or not. Because we need this label status in order to feed into the classifier later on. And all the data that I mentioned are in CSV format, which will be imported into graph database. Okay. The second step is the spam classification. Okay. What we need is the first one is the label tweet file, which is the CSV file that contain all the tweets that we collect. In addition to the text, we need to classify that whether each tweet is a spam or not. The second one is the unlabeled tweet, unlabeled CSV file, which our classifier will predict on this data, and we will use output. The classification step. The first step is to read the training tweet data file or CSV file into the Panda data frame. And the second one is to convert into feature vectors using TF-ID vectorizer. The third step is to split data into training and testing. And the next one is to use base as a classifier. Next one is to fit the classifier with the training data. The next step is to run the classifier with the real data that we would like to use later on. Okay, let me show you the code. Okay, I have the notebook, Python notebook here. This notebook will do the spam classification. I will quickly show you the code. First one is the import statement. It's nothing. Okay, this one is the training data. As I told you, it's a CSV file that we are prepared. We load the training data into the Panda data frame. Take a look at how many of the data we have. We run group by statement and count. So we have two classes. Label equal to 1 means it's a spam. So we have like 357 spam tweet. And for the 0 label mean the non-spam or ham. So we have like almost 10,000 tweets with not a spam. Let me show you simple spam tweet. Just print the sample spam. Here, they are in Thai language, so most of them are like recruit people to work online or try to sell something like that. The next one is to load the NLP because we need to analyze the the text data, and the text data here is in Thai language, so we need Thai NLP. So we have Pi Thai NLP to do the task. We import the Thai NLP, and then the next one is to abstract top hashtag from all the tweets from the training data. The next one is to write the code to tokenize Thai string into word. Yes, the code. And the important one is the TF-ID vectorizer. We need to convert all the text in the training data into feature vector so that the machine learning code can process them. So we use TF-ID vectorizer from sklearn to do the job. And we supply it with the stop word, which is a Thai stop word. And we provide the vectorizer with the tokenizer that I have wrote a little bit earlier. Okay, and we transform the data into the feature. Here's the result. The result have like 10,000 row and 6,000 feature. Next one is to load the classifier. We will use a naive-based classifier. Next one is to split the training feature into train and test dataset, so that when we train, we can verify that our classifier is good enough. Okay. Here we have a base classifier and fit with the training data. And after we fit it, we predict by using the test data. And we check the result by using score, accuracy score, precision recall, and ROC AUC. The result is promising because precision is like 90%, recall is like 96%. Next one is we use the classifier with the real data here. We load the real data and we use the classifier to predict. So take a look at the result. We have like almost 60,000 tweets, and we identify about 248 spam tweets in our production data. And we save the data into the CSV file. Okay. The second step is to import data into the graph database. We have user file, user underscore friend file, and status file that we need to import into the Neo4j database. So we copy the three files into import directory, and we run import command load CSV. And after that, we run Cypher command in order to make relationship between all the entity or all the node. Let me show you the code. The next one is the import code. Before we import, we created two constraints to make sure that things work properly. The first one is to make sure that user ID is unique. And the second one is to make sure that status ID is unique. So we create two constraints. The next one is to import CSV file into the graph database. The import command is here.
Hi,
We
Mananai.
use
Sorry to interrupt you
load
in between.
CSV command, and the file is the file in the import directory. And we do this in Python notebook, and we import 1.5 million users. Next is to import user friend relationship. So we have another CSV file, user friend in the import directory, and we use load CSV to import the relationship. When
Hi,
after a
Mananai.
while,
Sorry
yes.
to interrupt you in between. We need to wrap it up in next 1 or 2 minutes.
Oh, okay, sorry.
Sorry.
Okay. So we load user friend, and the last one is we load status. Okay. Okay. After import the data, here is the schema. So we have user status and spam. The last part is the network analysis part. So we do visualization, triangle analysis, and community detection. Here's the notebook of the analysis. Because of the time limit, so we go into the picture. I use some Cypher query here in order to show the spammer, and use the NX visualization library in order to show the spammer. So from the picture here, you can see that all the spammer, or a lot of them, are connected together, which means they are friends or they work together. The next one is the triangle analysis. Okay, so we have we will check whether we can identify more spammer by using triangle, but unfortunately, I cannot see any relationship. The last part is the community detection. I run the Luen community detection in order to see group and spammer in the group. Let's go to the result. So here we have a lot of community. The first one is like 2,700 people in the group, and we have like almost 500 spammer in the group. But this is only about 16%. The most important one is this one. The group size is 300. Sorry, this one. The group size is almost 200. But we have like 177 spammer in this group, 92%. So almost all spammer are in this group. We have some Cypher query in order to check who are not spammer in the group, and we list that here.
Mananai, sorry to break you again. We are actually out of time now. I've already stretched a bit. Can we wrap this session quickly?
Okay, sure.
We are out of time. Do you have more slides to cover? Can we just do it in next 1 minute if possible?
Yeah, sure. Okay. What I would like to say is that by using community detection and the algorithm we use now is Luen community detection. So the Luen community detection can detect some spammer in the Twitter network, and one community have a lot of spammer. It's like 90% of the community is spammer. And after we check the rest that are not spammer, we can conclude that the rest are spammer also. conclusion here is that spammer work together, and community detection can identify more spammer that not initially detected. That's all. I hope you enjoy the presentation.
Thank you. Thanks so much,
Thank you very
Mananay.
much.
I'm really sorry I had to cut you short. We are really short on the timeline right now. But yes, do stay by, and there are folks who are asking for GitHub repo link in the chat window on Hopin.
Okay.
So would request if you can share it over there after the session. Thank you. Thanks
Okay.
once again. All right. So moving on, next we have Tommy. Tommy is a student at Tongji University, and he's going to talk about Neo4j lectures of the Stanford CS224W course. Let me have Tommy on screen. Yes, we have Tommy on stage. Thank you, Tommy, for joining in.
Okay, let me share my screen.
Sure.
Thanks, Sid. It's so pleasure to join the Nodes conference, and I finally have an opportunity to share my experience on machine learning with graph with all over the world. Actually, this is my first English presentation, so I'm a little bit nervous, but fine. So my lecture will be 15 minutes. And first, I will introduce you my video channel. And then I will introduce you the best lectures about graph machine learning. That's Stanford CS224W. This is very good lectures. So let me introduce my video first. This is my video channel. You can use this link URL to get access to the bilibili.com webpage. And my video channel is about machine learning, deep learning, also convolutional neural networks, computer vision, as well as AIGC. This video is about to use AI to draw pictures in science fiction novels. And I also made lots of videos about AI paper reading in object detection, image classification, as well as image segmentation and machine learning with graphs. And recently, I made a series of lectures about explainability of AI, also called XAI. That's open the black box of a machine learning algorithm and know it, explain it, and trust it. And this videos is about augmented reality. You can use these tutorials to make your own AR gift for your good friend or your company. This lectures is about AI paper reading about graph. That's deep work and Neo4j, as well as GNN. That's about graph neural networks and graph machine learning. I also make a lot of videos about data mining, data processing, and machine learning basics. So that's my video channel. I have been working on this video channel for 4 years, and I'm now a good uploader in China, and maybe you can watch my videos in the future. And I also make lots of applications and projects using Neo4j. For example, this is a medical question answering application. You can enter your question, and the graph database will give you its answer. This is nodes and attributes. Also relations. Using GDSP, Graph Data Science Playground, you can do lots of data mining about graph. Yeah, and then I would like to show my AI paper reading, and this is my best work, I think. I make tons of notes about many famous paper about artificial intelligence. And this paper, I have been working on these papers. This papers is very famous and have very influential power. And every student in China, or maybe every student in all over the world, will need to read these papers. And I make tons of notes and make videos to read this paper sentence by sentence to let you learn this paper better from the beginner. That's so-called from zero to hero. In graph machine learning, I also make lots of paper reading and notes. For example, this is deep work, represent a node embedding algorithm, a classical node embedding algorithm. And this is Neo4j, also node embedding algorithm. And I would also like to introduce bias with you. This is a biomedical information ontology system. And you can query many medical terms, such as COVID-19 or some, for example, fever. And you can query many medical papers. It has a lot of knowledge graph about medical. Okay, and then I would like to share CS224W with you. I think this is the most exciting and the best materials about graph machine learning. If you are a beginner, if you are a freshman in graph machine learning, I would like to recommend these courses with you. Let me introduce its schedule. First is machine learning for graphs introduction, and the teacher, this teacher is the author of Neo4j, will introduce the history of graph machine learning and classical methods and advanced methods about graph machine learning. And in lecture 2, traditional methods for machine learning on graphs. He will introduce some classical traditional methods before deep learning. And from lecture 3, it will be node embeddings algorithm such as deep work and Neo4j. In lecture 4 is a famous PageRank. Google used PageRank to build its first search engine, and this is very famous in graph science. From lecture 5, the teacher introduced GNN, graph neural networks, and it also tell us some ideas, some design architecture in graph neural networks, and also applications of graph neural networks. He will introduce such as AlphaFold 2, and use graph neural networks to build your recommend system, to build your drug designer, and use GNN to do some AI for science work. That's very exciting, and also frontiers about artificial intelligence. In lecture 10, from lecture 10, it will be knowledge graph, and this is also a basic topic in graph science. And from lecture 13, it will be some applications about GNN, such as community structure, such as deep generative models. We can use AI to build another new graph. Also, some advanced topics on GNN. This course is totally free, and you can search on YouTube to watch its previous lecture. Also, slides and videos. Also, it offers many Colab homework, you can run directly using Colab. You need to have some Python basics and machine learning basics. I think graph data mining and graph machine learning will be vital importance in the future, as graph data structure will be more and more important, such as in AI for science, medical design, and the social network, social relationships. Also, many papers also have social relationships, has links. And I would like to introduce you another platform. This is a Chinese paper reading platform. Its name is readpaper.com. And you can search paper, make notes of paper, discuss paper, and connect papers. For example, I would like to search deep residual learning for image recognition, also called ResNet. And you can see its connections, its citations, and the papers whose citations is it, the papers who cite it and its citations. It's also a node link structure, also called graph structure. Just like connectedpapers.com, and the graph structure will be more and more important in the future, and also graph machine learning will be more and more important in the future. So if you are a beginner, if you are a freshman in college, or if you are a totally freshman in machine learning, and I would like you to learn graph machine learning from the beginning using CS224W, this course. So that's basically my lectures. Sid, do you have some questions? Yeah,
all right.
15 minutes.
Thank you. Thanks, Tommy. It was a great session.
Yeah. Should we have QA session?
Yeah, that's what I'm just checking if we have Q&A in the chat window.
Yeah.
But more or less, your links have been shared with everyone. Let me just broadcast them for everyone.
Yeah. And especially in China, we have a very poor fundamentals of graph machine learning tutorials. So these lectures will be very important for Chinese students. And I hope there will be more courses and lectures like this in China.
Definitely. This is awesome. And I think Jason is asking for the link to Bilibili as well.
Of
Would you mind
course.
sharing it with me or in the chat window directly?
I will send it to you.
Cool. Yes.
Bilibili.com is just like YouTube in China, and many teachers and students, they will share their knowledge, share their experience about learning on Bilibili.com. And that's like a learning website.
All right. And that's it. Thank you. Thanks so much, Tommy.
Yeah,
I think there are no questions as such, but it
see you
was a
next
wonderful
time.
session. Yeah. Cool. So we have our next speaker ready, but we still have time before I bring the next speaker on stage. So allow me time for the next 3-4 minutes. Stretch for a while, have some water, and we'll be back soon. Let's enjoy some music meanwhile. All right. So after that rocking music, we have a rocking performance by Jack, Jen, and David. Let me have Jan on stage. Jan is senior software engineer at Manta, and David is team leader of architecture at Manta. And both of them are going to talk about track data lineage with a graph database. Thank you for joining us, Jan.
Thank you, Sid. Shall I start?
Yes, you can.
Okay. Hello, my name is Jan Jacques, and I am a senior software engineer at Manta and a consultant. And I'm here to tell you about how Manta uses Neo4j graph database to track data lineage. My colleague David Buchek, he's not here, unavailable, unfortunately, but he prepared the video. So first I'm going to play David's video where he is going to explain the business use case behind Manta. And then I'm going to show a little bit more details in depth about how Neo4j graph database enables us to achieve the business goals. There is going to be a time for Q&A after the talk, so you can, of course, prepare your questions ahead, and I'll be here to answer them in the end. All right, let's go.
Hello and welcome to our presentation. We are from Manta company. I'm David Buchek, leader of architecture, and my colleague who will be presenting later on is Jan Jacques. He's in charge of graph databases here in Manta. Our talk today is about the data lineage, tracking data lineage with graph databases. But first, let us introduce me, Manta. Manta is still a startup company. We started in Prague, like a startup, growing really fast. Our customers are big enterprise companies. Recently, we received nice financing. So right now, we are really hiring, really growing. We opened a few new offices. We have office in Prague, of course, in Lisbon, in Tampa, in Dublin, and trying to still grow. So what we are developing, our product, and we are a product company. Our product, it's Manta data lineage tool. And we'd like to tell you today what actually is data lineage. So on the first slide, you will see a really brief introduction what data lineage is. Basically, data lineage represents a detailed map of all direct and indirect dependencies between data entities in the environment. It's a really formal way how to explain it. In normal way is just imagine the large systems, and the big enterprise company have hundreds of them. And they want to know how data flow from one system to another. So basically they use a data lineage for automated mapping flows, data flows between those systems. You can imagine like that some data start and some ETL are written to the database, and from the database it flows to the reporting system. The part of data lineage is also data processing. So data on their flow could be calculated somehow, transferred, and so on. The proper data lineage can also map or, let's say, analyze and store even the data transformations. And that's the Manta tool. So, speaking about data lineage, there are basically three types of them. The first one is a static data lineage. It's about the reading or deducting data lineage from static metadata. Let's say we are speaking about database. So we can read the SQL DDL schemas, analyze them, and deduct the data lineage from them. That's what Manta do. The next two are runtime lineage. You can have a system which can read logs or system calls and deduct the data lineage from system calls or method calls or procedure calls. And the third type is record lineage. You can have a sound and listening actual data traffic, and you can map those data traffic into the data lineage. So that was a really brief introduction what data lineage actually is. And in the next slide, I'd like to introduce you some unique features of Manta product. We support wide range of technologies. We support 50+ scanners from SQL databases, reporting tools, ETL tools, and also some programming languages like Java, COBOL, Python. Some of them, are in experimental stage, but as I told you, in the first place, we are growing a lot, so I will keep improving and so on. The next important feature is automated mapping. So we develop unique way how to automatically map those data, how to automatically connect them between several systems. So there is just few manual things really necessary, and we are trying our best and we are doing our best for automatization. And the third really unique feature are revisions. We are able to scan the source system over and over and record all changes in the time. And then we can see and we can work with the differences, how the systems are changed in time. I will tell you later in the real use cases. If you want to know more details about data lineage, we have a really nice ultimate guide to the data lineage on our pages. I strongly recommend you to read it. Okay, right now I'd like to tell you about some real use cases, how Manta product can help our customers with their systems. Just first real use case. There are more than 3, but I'd like to introduce just the 3. The first one, very often, is regulatory compliance. Every big company, or most of them at least, such as banks, insurance companies, and so on, are under strong regulations. Let's say GDPR. So the regulator can arrive to the company and ask, how can you be sure that you deleted all your sensitive client's data when the client asks? How can you be sure? And the Manta helps them to identify all places where the sensitive data is stored, and they can easily persuade and prove regulator that they are covering all those places, and if their clients want, they deleted everything from their systems about their client. So they easily can persuade and prove to the regulator they are compliant. Next is data governance. So a lot of companies in this scale and this size, the enterprise companies, have a lot of systems. I mentioned them before. And they, very often, they are not sure about the impact. What happened if they change one systems? What happened to the other systems? And they want to be sure that they cover it and they will be safe during data migration or during the changes of some interfaces. The normal way is just send a couple of emails, try to thread everything by hand, asking developers of the other systems and so on. And of course, like they know that sometimes they receive answers, sometimes not. But If they have Manta, they could map all those systems, and they easily know what happened if they change the interface of one systems. How will we impact the other? And the migration changes of interfaces are much easier, more error-proof. And the third use case I'd like to mention is data operations. So I mentioned before, we can record all changes in the systems. So what could happen? They could easily track what algorithm changed in the time, in the past, and how. We had one story from a client from the Big Bang, and they suddenly have a problem because their client, possible customer, arrived and asked for a loan, and he was rejected. And the same guy arrived in 3 months, and he was accepted. And because it was in the United States, he sued the bank for discrimination. And the bank wanted to defend themselves, of course. And they claimed they changed the algorithm. But the judge asked how. But fortunately, they had Manta. So they could went back in time, check the algorithm, show it to the judge, and he said, okay, there is no case of discrimination. You change it from technical reasons. And our customer was able to prove it thanks to Manta. So that's how Manta helps our clients. Now, let me show you the very, very brief demonstration of Manta, the part we called viewer, how the data lineage look like. Now you can see is a Manta viewer. Here on the left part is a structure of the scanned systems. Here, as you can see on the root level, let's say, there are technologies we scan. There is like approximately 10 of them. And what I wanted to show you here is one table from graph database. In this case, Oracle. So now I'll take the one item from the tree, one table, and click on visualize, and I'll see how does it look like. So I can open those tables, and you will see columns. And you can easily track the source, let's say in this case currency code, how it flows across the systems, and to the next systems, to the final record, into where data usually ends. It's very intuitive, and it's clear how data goes through. You can use another column and track another column and so on. That's basic, simple work with this part of the Manta systems. All right, we are here to introduce you the graph databases, how Manta work with databases. So graph database is actually our metadata store. What we scan, what we analyze, everything is stored into the graph database. Here on this slide, graph database structure, vertical graph, we store all hierarchy of the systems. The root here in this case is a resource. It could be like an ETL tool, graph database, and so on. And under it, we have a node we call asset. It could be anything, again, which belongs to that resource, to that technology. In case of SQL database, it's table or schema. And under it could be column and so on. Here, we have a leaf asset. A leaf asset is the last in the hierarchy. And of course, in case of SQL database, this is a column. This is the last one in hierarchy. The relationships between them are has parent. So if leaf asset is a column, has parent is a table, and between resource and table could be schema and so on. And this hierarchy depends on the technology. On next slide is a horizontal structure. So this is a way how we actually store the direct flow in the databases. We connect just only leaf asset by databases by direct flow. And now we can see all together how it's really represented, a little bit simplified way, but how it's represented in the graph database. So there is a horizontal structure, technology hierarchy, and also flows, which are leads just from the leaf asset to another leaf asset. Here is shown how more technologies are come together. Every technology have their own hierarchy, and those hierarchies are connected on the leaves by data flows. That's how we store it in the database and where we are doing our graph database queries. What we scan, how we get the data from the source systems into the graph database. We usually start with some SQL database definition. Here on this slide, you will see create table, export card fields. We have special analyzers, and they parse it, and they create the middle product, AST. The middle product are filtered again and stored into the database in the structure we are already familiar with. So you recognize the technology, it's here, in this case Oracle. This is a table, export card keys, as you have seen before, and it's columns. And in this structure, with this structure, we can very flexibly work. We can export it, we can show it, we can transform it, and it could be shown in the viewer, in the form I showed before in the demo. Now, and this is a place I'd like to ask my colleague to continue with the presentation, and he will show you some differences between graph database and SQL database.
Thank you. Thank you, David. I'm sorry for the sound quality. We'll try better next time. David showed you the interaction about the data lineage business use cases in Manta, and I'm going to continue and give you a little bit more details about the benefits of using Neo4j Graph database compared to relational databases, and how this is crucial for us because of the performance. Previously, even before I joined Manta, Manta used a relational database with SQL queries. Relational databases are, of course, a natural choice for common applications. However, given our data structure that David showed you in his video, you could guess that our queries are recursive in nature. This is an important factor that affects the overall performance. When using a relational database, each join using a B3 index has a logarithmic complexity to the total number of rows. And with recursive queries, the number of joins equals to the length of the relationship chain. There are some relation databases which provide syntactic sugar for graph queries, such as Oracle or MS SQL. But since the underlying data storage is still based on tables, it's not natively fit for graph traversal queries. So the syntax helps only the developers writing or reading the queries, but the overall performance of relation databases stays the same or similar. Now let's compare with Neo4j, which is a native graph database. The most important feature for us of Neo4j is called index-free adjacency. It means that relationships are modeled and stored in a way that allows traversing from start nodes to adjacent nodes without using any index in constant time. And this traversal can be in both directions. It's equivalent in performance, so it doesn't matter if the data are connected from a start node to an end node or in the opposite direction. I'm going to show you two examples of queries that we have in Manta to compare how graph queries can look like in a relation and graph databases. In the examples, I'm going to use the same data and colors. Red are the uppermost resources, blue are the non-leaf assets such as database tables, and white are leaf assets such as columns. The first clear example is finding the asset hierarchy path in our database structure. In a relation database, there could be a table asset with columns ID and parent ID, where the ID is the primary key and parent ID is a foreign key. The data could look like this. Check the content of parent ID column. The first row is effectively the root of the hierarchy tree, so it has parent ID null. The second row is the second level of the tree, so it references the root ID. And all the other rows are on the third level of the tree, so they reference the row on the second level. Let's say that we want to find the asset hierarchy path for the asset fee amount. There are various ways for writing such query in SQL. You could write it as a loop assigning an intermediate results to a temporary table. I have chosen a recursive join for the example. I'm not sure if you are familiar with the syntax. I'll quickly highlight the important parts. There is a where condition for the starting point, the start node fee amount with ID 6. And there is a join condition where the actual recursion happens. It references the parent ID and the ID table, ID column from the same table. And this is the result. The query contains the result is the full path, in this case 3 rows, which of course can be longer in case of more detailed hierarchy. From bottom to up, there is a start row, the fee amount that we queried for. Its intermediate parent, export card fees table, and the uppermost parent Oracle database. Now, in a graph database, as you can see, there is no need for artificial parent ID for foreign key column. Relationships are first-class citizens stored in a way to allow as fast as possible traversal. The Cypher query returning the same results as the previous SQL query could look like this. The where condition is similar, but the recursion is described by pattern matching the path in here. The relationship is repeated unlimited thanks to the asterisk in the query. In real cases, sometimes it's common to limit the traversal to a reasonable depth, such as 20. But for this simple case, I'm going to show you the case with unlimited traversal with the asterisk. The result is as expected. We've got the same hierarchy path as before. Again, from the bottom to up, there is the start node fee amount column, its immediate parent export card fees table, and a database and the uppermost parent Oracle database. I'll show you how it looks like in our application. There is a tree on the left side where you can see the actual data. Sometimes it can be more nested. In this case, there is the database server and there is database schema. Here is the table, and here are the columns inside of the table. In the metadata, we can see the full path coming from top to bottom. Now going back. The second example I'm going to show you is visualizing the data flow. In our graph database structure, we are connecting only the leaf assets with flow relationships. Leaf assets on the bottom of the tree. When user wants to visualize the data flow at the lowest detail possible, for example, table columns, it's simple, going from left to right. So we just start the traversal query at the user's chosen leaf asset and follow the flow relationships and show user the result. However, when user wants to visualize the data flow at the higher level of detail, for example, between tables or even between databases, now you see that there is a potential issue. We don't have the flow relationships between non-leaf assets because it would cause unnecessary redundancy and duplication of the data. So what we have to do is to combine the flow traversal query with the other query to traverse asset paths from any level chosen by the user down and up to the leaf asset level. We start the traversal query at the user's chosen non-leaf asset and follow the hierarchy down to the leaf asset. From here, we follow the flow relationships, but at each traverse leaf asset, we have to make a side turn to find the non-leaf asset up here at the user's chosen level of detail so that we can show the results on his chosen level of detail to the user. We start the flow relationship between leaf assets only because we need the flexibility of graph queries so that we can implement and experiment with different kinds of flows. We have not only direct flows, but we also have indirect flows which represent filter conditions and other types of flows like mapping between different layers like physical or logical. As you can see, there are a lot of potential graph traversals in this query, and this is where Neo4j graph database helps us a lot with performance. I'll switch back to the demo again. I can either, I'm going to show you the difference. In the tree, user can select either a column and visualize it. So the result shows only the flows from the column to another column in talent the ETL, to another column in the ETL, and so on. But when I go back and select the table, now the visualization gets simplified. It shows the flows between from the table to talent the schema and so on. And I can choose to drill down and see the details of the flows. This is the lowest detail possible, which might be too detailed for some users. So that's why we are offering also the possibility to visualize the high-level data flows. So that's about it. We gave you a short introduction about the data lineage use case. Data lineage is a detailed map of dependencies in a complex environment, which can consist of various databases, ETLs, and reporting tools. Manta is able to scan the whole environment with only a read access to database metadata, potentially also source codes like SQL, DDLs, or stored procedures, and create automated mapping between metadata. Based on the metadata, Manta can show the visualization of the whole environment. And Manta uses Neo4j because of the performance of traversing of our metadata repository and for flexibility so that we can continue evolving the product with more graph-based queries. Thank you. And now I'm ready for your questions. Let's see if there are any. Again, I have to apologize for the sound quality in the beginning, but I'm ready to answer any questions that are here.
Awesome. Thank you so much, Jan. And let's take a look if you have questions in the chat. Oh, yes, we have one. How to build a graph structure in data that does not show correlation?
Well, first of all, we rely on customers' metadata. Our customers are enterprises like banks or telecommunications, which use a lot of SQL procedures, for example, that allows us to connect the data that shows the correlation. But of course, sometimes the metadata are incomplete, and we also allow to import custom links in the database, so that if there are two separate trees in the database, like separate database and separate ETL and a separate reporting tool, and it's not connected, we allow to import custom links to show the correlation for the end users.
Got it. Awesome. And then we have one more question. I think this was related to David's talk when he was presenting. Person in back understands the use case, but he wants to understand where to start and can you start small. So if you have anything.
I think this is hard to answer because we are aiming at the large companies which has tens of years of legacy IT systems where employees join the company and leave the company, and there is a lot of inside knowledge that sometimes gets lost. And our tool helps the customers to map the whole environment and make it easy to understand even to newcomers. So, well, starting small, usually when you start a small application, then well, you start it from scratch and you have all details in your head, or if there is a team, then it's properly documented in case of a new application. But we are aiming at cases where the documentation is not perfect, or when we need to map the whole environment and there are gaps in it. So yeah, I'd like to start small, but it's not. This tool aims for the hard use cases.
Cool. All right. I think that's pretty much in the chat. We have the questions. Let me just see if we have more available. No, I think that's much. Thank you so much. Thanks to you and David both for joining us at Node, and we look forward to having you for next year as well.
All right. Thank you for having me here.
Thank you so much.
See you next year, probably.
See you. Bye. Take care.
Bye.
Great. So this was a really exciting session, and the one that's coming up next is something which I was looking forward to personally since the time we were planning for Nodes. The next one is going to be exciting, but there's still time for it. There's 8 minutes left. So don't go away. Do join us back in next 8 minutes. We'll be starting up shortly. Let's have some music meanwhile to help you daydream. All right, all right, all right. I hope the music has not put you to sleep, because the person who is going to come next will definitely put you to sleep. Okay, so bringing on stage, we have Anton, who is going to help you and give a space to relax with a guided meditation. He is a software engineer, a kernel team at Neo4j, and also a mindfulness teacher. I'll not wait you hold you from what Anton is going to do today. So over to you, Anton.
Thank you so much, Sid. And hello, everyone. I'm happy to have you here. So I thought we'd do a short guided meditation session together. And I hope this can be a space for you to breathe, to take a break, to maybe find some calmness, maybe find some centeredness, and go into the rest of your day re-energized. So as Sid said, my name is Anton Persson. I'm seated in Malmö right now. And I have the great pleasure to host a guided meditation session at Neo4j every Friday for my colleagues. All right, so let's dive in. So I invite you to sit down for this session and come away from the back of the chair a little bit so that your back can support itself. So sitting with a straight back, but not too tight. So this will help you to stay alert and focused, and at the same time, relax. So planting your feet steadily on the floor, feeling the solidness, the stability of the floor. Seat is heavy on the chair. And I invite you to close your eyes. It will help you to turn inwards and to take a break from the outside world. Arms resting in your lap, palms facing the sky or facing the earth, or maybe folded in each other. Find a way that is comfortable for you, that helps your body to relax. You roll your shoulders a bit, adjusting the neck, stretching a little bit, flexing the spine. Just making any alterations to the body. And you can, to find the balance, you can tip a little bit forward and backward, and making the tipping smaller and smaller until you find a point where it's balanced. And then you do the same thing side by side, finding that point of balance where you can sit straight with that as little effort as possible. And it doesn't have to be perfect. We're just trying to invite the body to be comfortable. Letting the shoulders drop, letting them down, unclenching the jaw, letting the jaw drop a little bit. Face relaxes, softens. And the area between the eyebrows, check if there's any tension there and see if you can just let it go for now. And I invite you to join me in taking a few deep breaths. So breathing down into the belly and filling up the chest in through the nose. And we're gonna hold it a little bit on the top of the breath and then exhale through the mouth to the breath will help the body to relax and to release any tension. So breathing in through the nose, all the way to the top, and hold. Breathing out through the mouth. One more time, in through the nose. Filling the belly, filling the chest, hold it on top. Relax, let it out. And one last time. All the way down into the belly, chest, hold it, and release. Letting the breath return to its normal pace. And now you're just sitting here. There's nothing for you to do here. There's nothing in this session for you to understand. There's nothing for you to know. There's nothing for you to plan ahead for. Nothing to achieve. Your to-do list will be there waiting for you when you come back. But for now, you can just leave it be. All of the things that you need to take responsibility for, that you want to take care of, just leave it outside for now. Taking a short holiday, short vacation. Letting go of any doing and just being here, just sitting here in this moment. Notice that your body is breathing. Your body is breathing all on its own. You don't need to take care of that. But sense in where in the body you feel the breath the most clearly. If it's in the nostrils, or down in the chest as it moves with the breath, or down in the belly that inflates like a balloon with the breath. So check where you notice the breath the most clearly. And then you just stay with your attention there, following one breath at a time, following the inhalation, the pause, following the exhalation without rushing it or controlling it in any way. Staying in the pause in between. And then continue like that, one breath at a time. And whenever you become distracted, and most likely you will many times, by outside sounds, other bodily sensations, thoughts, or mental images, just as soon as you notice that, just give yourself a smile. There's no need for self-criticism or any judgment or beating yourself down in any way. We're actually not in control of our mind wandering, so there's no need to be hard on yourself for it. But as soon as you notice you become distracted, you are back again, you are aware again, and you can decide to guide your attention back to the breath. So this is the practice, to stay with your attention on the breath, and when there is distraction, wake up and come back again to the breath. Just following one breath at a time. The only breath that you can experience is the one that is happening now. The previous breath is already gone, and any future breath is not real yet. The only one that actually exists is the one that is happening now. There may be other things going on in your awareness. You might notice bodily sensations or thoughts. Perhaps your mind is very shattery. Mental images. And it's fine. Any of those things can be there. You don't need to fight it. You don't need to push anything away. You don't need to take care of it in any way. But leave it in the background. Don't engage with it so much and stay with the breath, the focus on the breath, and let that be in the foreground, in the center of the stage. And if there are thoughts like, it doesn't work for me, I cannot do this, am I doing it right? Should I do it more like this or that? You don't need to engage with those thoughts. They're just thoughts that show up. There is nothing for you to do here. There's nothing to perform perfectly. All you need to do is just stay with your attention on the breath. That's all. Noticing that the breath changes every moment. The inhalation has a movement of its own. The exhalation also moves in the body. It's not static. If you can bring some curiosity to your breath, what does it actually feel like to breathe? Letting the attention just float with the breath like a river. And you can let go of the breath. Start noticing the sounds around you, opening up for other bodily sensations, to feel your body opening up to the room around you. And before you open your eyes again, I invite you to set an intention to bring with you this inner state of relaxed focus and bring it into the rest of your day. So you don't need to leave it here just because the session comes to an end. And you can open your eyes again and start coming on back. I hope this session was useful for you in some way. And I will stay in the chat for a bit if you want to talk. Otherwise, I wish you a beautiful rest of your day. Bye-bye.
Thank you. Thanks so much, Anton. That was really relaxing.
I'm glad.
Cool. We'll give the audience a little time to come back to the normal state. I'm sure they're able to unwind themselves with this amazing short meditation session. Really, really helpful. Thank you so much.
Thank you for having me.
The audience would look forward to your love in the comments in the chat window for Anton for his amazing session.
Thank you, Marilee. Thank you, Rosie. And hello to yes. Hello, Raditya. Not sure I pronounced that correctly. Hello, Jenny. Thank you for joining. Thank you, Raditya.
So we have 3 more minutes, so you can all stretch up your legs. Just we are in a relaxing zone now. We are almost there towards the end, but we have 3 exciting sessions lined up before we jump to the closing Q&A with Emil and Andreas. Let's have some music meanwhile. Let's go into the space.
Okay. I will sign off now.
Bye.
Bye, everyone.
All right, so it's time for our next session by Pierre. Let me have him on stage.
Hi
Pierre
everyone.
is
Hi,
pre-sales
Steve.
engineer at Neo4j. Welcome, Pierre.
Well, thank you for welcoming me. It was so nice. I'm really relaxed with this meditation session, so
That's right.
I'm happy to do this talk. Yeah.
Same here. Like it really invited me. Like
Yeah.
amazing session. 15 minutes. Like I didn't know that 15 minutes is all it takes.
Yes.
Awesome. Thank you. Thank you so much, Anton, once again. And over to you, Pierre. Can we
Sorry.
have your slides?
Okay.
I think we can get started with you.
Okay. Let me share my slides.
Sure.
Here we go. Do you have it? Yes.
Yes.
Okay. Very good.
Cool.
So let me start. Okay, so I'm really happy to do this talk because it was a lot of fun to get it prepared. So I will talk to you about state machines and nice things we can do with them. I'm Pierre Aftermeyer, I'm pre-sales engineer at Neo4j. So let me start. So what is a state machine? We also call them a finite state machine when they are finite, and they will be deterministic finite state machine. They will be deterministic in our context. Or I'll say automaton or automata plural, FSM as an acronym. What does Wikipedia says about them? So finite state machine are a mathematical model of computation. It is an abstract machine that can be exactly one of a finite number of states at any given time. The FSM can change from one state to another in response to some inputs. So we have states, we have inputs, and states change with those inputs. An FSM is so defined by a list of its states, its initial state, and the inputs that triggers each transition. So we have state and transitions. It sounds like nodes and relationship to us. So let's see it as a graph. Here is an automaton for language recognition. We'll call it the LOL language. So how does it work? I will try to find out if the word haha is recognized by my automaton. So I am in the initial state because there is the arrow, and I will read the first letter of my word, H, and that will get me to the state 1. So I have 4 states here. Then with the A, I go to the second, to the state 2, then with H to step 1, then 2 again, and with my exclamation mark, I get to the state 3. It is a terminal state, so my word is recognized by the language, is part of the language. So I have a machine that is able to recognize a word from a set, from a language. And this is the first say use case of automata. I need to put those automata in my database because we are working with Neo4j, it's a database, and I'm trying. I need to express them as data. There is a very straightforward mapping from my automaton to a CSV. Here, for instance, the yellow state is the first line, and the red transition is the red line, and we can see it's very easy. So when I have it in a CSV, I can ingest it. also can ingest several automata in a single file, in a single CSV file. Here I have 3 languages, say the ABC star language, the LOL language, what we have seen, and the Python var language. A Python var is an alphanumerical string that does not begin with a number, and underscore are accepted. When I have several symbols in my transition, you can consider it's a list of admitted symbols for this transition. So we are ready to ingest. To ingest, we can use the Neo4j data importer. It's an awesome tool if you want to prototype a very fast database. So you should use it. And tada, let's see if it works. So I have an Aura instance. I have my state machines data file. My importer, I've already imported it, but if it's really easy, you draw the meta model with transition from state to state, and you can ingest your CSV from a very easy mapping. There is no code. If I do a preview, I see my automata are in the database, so I can query them. I can show you all state machines with a very easy query in my database. They are in my database. Then I can create a word to see if it works. I will create the word as a chain list of symbols. I will init my computing. I need some really straightforward code, and I'll set the language to the LOL language. This is the language against which I will check my word, and I can iterate each state and each transition with code I will explain later. If I want to iterate all state, I put it in an APAC periodic commit, and I have all my process done, and I can check if my word is part of the language, and here is accepted language. When I have it, I can build a tool to check if a word is from a language or not. For instance, from the LOL language, I can check if this word is accepted by this language, but maybe it's not by another one. It's not a valid Python variable. If I remove the exclamation mark, then it is. I can put an underscore at any place, and it will also be good. So I have something functional, a very straightforward way to build an application with a finite state machine. How do I process a word with an automaton? It's very easy. I have the chain list of my symbols and my automaton. The blue state is the current state, and this state is the first unprocessed state. And then, so first unprocessed, current state. So then, as it's an H symbol, I will trigger this transition to this step. And it's really straightforward to write this in Cypher. This is the first unprocessed, maybe the first of all of them, or the first following a processed one. This is the current state. This is the transition that contains the symbol I'm referring to, and this is the next step. When I add this, I can update my current objects really in a really easy and straightforward manner with Cypher. And I used Neodash for the front end because it's it's a great tool you can use for prototyping a front end very fast. So I encourage you to use it. So we can use automata with Neo4j, but what are they good for? And first of all, I want to share an intuition with you about control flow. Control flow in a programmation language is like structured like for loops, while loops, if then else. It enables you to control the flow of your code. And we can see that some automatas are really close to control flow. This is a while loop. While true, while I see the true event, I'll stay in my loop, and when false, I go to another state. And this is a if then else statement. I have a Boolean value. If it's true, I go to some terminal node. If it's false, I go to some other terminal node. So there is a mapping between automata and control flow structures. And we can build more complex control flow structures with automata than we can do with normal code. Now, what are automata good for? Some use cases. This one is from a puzzle of Advent of Code hackathon. It's bytecode parsing. You have to find packets in bytecode. Bytes are queued in the green chain list, and you have your orange automaton at the center, and you are like gluing state to sequence of bytes to find your packets. There is a link on my GitHub. You can find the code there. Then you can control the gameplay of any game with an automaton, and the automaton orchestrates the gameplay. It's like the referee of the game, and it can trigger any event from where you are in your gameplay. So this is a dice game with 2 players, and you can see there is code in a state. A code is triggered and is inside the state. It's like meta programmation with graph. And I will use this strategy later to show you something. This is an AI problem. I have 3 workers and a toolbox, and I need to get them down, and they are not supposed to die in the process. And you have to find the best strategy to do it. It's an optimization problem. You have to do it in the shortest way. The code is on my GitHub too, if you want to see. So let's go to a deeper dive in some use case. This is the way I log my workout with my phone. I have NFC chips there, and when I work out, I do deadlift 130 kilos and 3 reps, and it's the way I do. So I can trigger with my NFC enabled phone an event, and I add an event to a chain list. Here I do bench, and I have an automaton to parse this. I can put an iterator on the last event and the current state, and then it can see the next state would be there is no wait anymore because I have changed my exercises, and it has used the transition move. and there is code in this transition that triggers code, and that set a memory to the right values, like move has changed and weights are now empty. I put that in an APAC periodic to reiterate it all, and I can data is not actionable. So what was only some chain of events, I will do it. I will process the data right now. I have an iterator with my state machine and my data, and now I can. Sorry for that. Passwords are sometimes okay, and now I can see I have reps in my database. I can see all my reps. No, it wasn't. I wanted to show you sets of work. So yeah, I can see I have, for instance, a deadlift set with 3 reps at 150 kilos. So and I can build an app with that in a really straightforward manner. I can see I'm benching this month. Those value 1 rep max was 115 this week. So I have an actionable data from non-structured sequence of events. So thank you. That was what I wanted to show you, and I don't know if there is questions and if we have time for questions.
Sure, let me just check if we have more questions in the chat window. Just give me a second. Nope, none so far. It was a great session, I believe.
Okay, and I hope I've respected the time. Almost.
Yeah, you're well ahead of time.
How? I'm ahead of time. Okay.
Yeah, we have 3 more minutes.
Okay. So we can play with, for instance, I don't know, Python. There is another language you have not tested. It's the ABC star. It's from the so it has to start with an A, and then only ABCs. So it's accepted, and if I put a D here, well, it's not accepted anymore. Okay. Well, you can have fun, and I suppose it's also an accepted Python variable. It's the one I use most with foo, bar, and a by d, and playing with my keyboard. And yes, so it's the way I do my. This is the way I do my workout with my phone. NFC chips. You can use NFC chips for a lot of stuff at home. They are really cheap, and you can do fun things. You can put. I put them on toys of my children for their everyday routine to brush their teeth or anything. So it's a nice tool to use for anything. My GitHub repo will be in the slides, and slides will be shared. But my GitHub identifier is my full name. It's after Maya.
Yeah. Would you mind sharing it with me? I can just push it in the chat window.
Okay, of course. there are a lot of windows here. Sorry for
You can
that.
just push it on the StreamYard window.
Yes, yes, of course. Yeah.
All right, I've got that. Let me just push it. Here you go, John.
Then there is several repos about Automata. And
But I think we are right on time. Unfortunately, we don't have any questions from the audience. I believe the session was really exciting.
no problem. Questions welcome later if you have.
Yeah.
This is my email. If you can spell my name, you can send me emails.
That's right. Yeah. Thank you. Thanks so much, Pierre.
Thank you.
It was wonderful having you. Look forward to having you next year as well.
Thank you and goodbye.
Thank
See
you.
later.
Bye.
See you in next talks. Goodbye.
Bye. All right. So we are all set for the next one. Just give me a second. Let me bring in the next speaker on stage. Okay, so next speaker is Andrea. Hi, Andrea, can you hear me?
Yes.
All right, great. So Andrea is CTO at Lattice Business Automation, and he's going to talk about Saito Pi, seamless Neo4j integration in Python notebooks. This is going to be exciting. So over to you, Andrea.
Oh, we're just starting?
Yeah.
Cool. So hang on a second.
Yeah, sure. Feel free.
Yeah. So how I can share the screen present? Screen sharing. Okay. Can you see the slide?
Yes, I can see it. You're all set to go.
So cool. So thank you so much to everybody to be here. I guess that this is the end of the 2 days of nodes. I want to say thank you to Michael Unger and the whole Neo4j team that organized these 2 days full of great session, great talks. So today we are here to talk about Saito Pi, which is a seamless Neo4j integration in Python notebooks. And I'm Andrea Santurbano. I'm CTO at Larus Business Automation, which is a Neo4j partner. We are the first partner in Europe and the third global. Our, let me say, love relationship, love story with Neo4j started in 2011 when we did the first spikes, and then in 2014 became solution partner. In 2016 we had the we built the official Neo4j JDBC driver, and in 2018 we did the APAC, the ATL tool, the GraphQL JVM API. In 2019 we built the official Neo4j Kafka connector, and the next year the Neo4j official Spark connector. And we also partnered with Fujitsu, and we built the first AI-based solution on Neo4j, which led us to build our first graph AI platform, Galileo XAI, in 2021. So yes, we partnered, as I said, with Fujitsu, which built the Deep Tensor, a prototype of a deep learning engine with explainable AI that we helped them to productionize, and we included in our Galileo XAI platform. So let's see the agenda, why we are here. We will see how the Saito Pi integration works, and we do a quick demo. So why? Because in general, notebooks embrace diversity. So please consider these 3 common roles for any data-driven organization. We have the data engineer that can build, for instance, an aggregation table based on trillion of streaming events, and he can do that by using Scala API, Spark, and IntelliJ as IDE. And then from that aggregation table, an analytic engineer can build a streaming report about the streaming quality by using SQL and Tableau. And that report can be used by a data scientist, which can lead him to build a new streaming compression model by using, I don't know, for instance, R and RStudio or Python and PyCharm. Yes, even if at a first analysis, they seems quite different workflow, if we deep dive into them, we can realize that there are 3 common tasks that all of them perform. So they basically run code, they explore the data, and they present results. So, and this is basically what a data science notebook does. It allows to run code, explore the data, and present results via web interface. So this is why data science notebooks became the de facto standard for any data-driven organization, because it's the best environment to communicate the data process and share its conclusion. So how Saito Pi works? For us, it's, let me say, it's a journey. In Lars, we love notebooks. In fact, in 2018, we built the official Neo4j integration for Apache Zeppelin. Apache Zeppelin is a notebook runner, just like Jupyter, but it's provided by the Apache Software Foundation. And even if we think that Zeppelin is a great product, Jupyter outperformed it, so the market chose Jupyter, and this led us to do an integration for it, so Saito Pi. This is why Saito Pi is here. How it works? We basically use Python magic commands and functions. So it works on all IPython-based notebooks, so like Jupyter, the Databricks cloud notebooks, and others. And there are 2 kinds of magic commands that Saito Pi allows to use. The line magic, which can be used as an expression, and len magic generally returns a value that can be assigned to variable, and a sail magic, where after is activation can operate on multiple lines below the call. I will show the difference between sail and line magic in the demo. So Saito Pi is able to automatically recognize if your query returns a graph or a table, and display the data in the proper way. If you use it as a line magic, it will export the data as a pandas data frame if the query returns a result as a table, and as a network X graph if the result is a graph. So let's do a quick demo. The demo is based on the example available on the code repository, so you can go on the GitHub repository. We have the examples, and it's, as I said, an IPython notebook that you can open on Google Colab, so it's very easy to use. So the example is based on the crime investigation dataset from Neo4j, so you need to spin up a Neo4j sandbox just by clicking here. It's a process of very simple steps, so it's nothing so fancy. Then you have to go to the connection details tab and fill the variables here, just like I did. So then you have to run the paragraph. You have to install the Saito Pi integration from PIP. And once done, you have to load it. And then you can see the arguments that are allowed to pass to a line or cell magic in this very way, in this simple way. So you have here a set of arguments that you can pass to the Python magic. And yeah, let's use our first line magic. So basically, each magic must be activated by each line magic must be activated by a single percent followed by Cypher, and then you can provide the list of arguments. In this case, we are providing here the Neo4j endpoint, the URL, the username, the password, and then in the end, our Cypher query. So this is our Cypher query. And then we simple visualize it. So as you can see here, we have a data frame, and Google Colab renders it properly. But we can also we will also see how a cell magic works. So you can activate it by prefixing with 2% and then Cypher, and then you can write your Cypher query. In this case, we just want to check the metadata. So our graph model. So the graph is rendered by Cytoscape. You can pinch in and pinch out. You can click on a node and you have a tooltip with the properties of the node, the same for the relationships. And yeah, it's quite straightforward, no? So, but as you notice here, there are no colors attached to the label. It seems all very flat. So we want to attach colors to our graph, and you can do that by defining a simple, just an important thing. As you can see here in the subsequent call, I didn't repassed again all the connection properties because they are stored internally. So you need to provide them only the first time. So yeah, coming back to colors, how we can define them, basically defining a dictionary, and in each key of the dictionary, we define the label, and the value is the color. And then you can pass the colors with --co and the colors variable. So let's perform again our call. Oops, I forgot to run the colors. Okay, so and as you see here, we defined four nodes for the colors, and they are colored properly. So yeah, so in this notebook, as I said in the beginning, is based on the crime investigation dataset, which use the POL data model, which is focused on, which is an acronym for person, objects, location, and events. And yeah, it's used for investigative and security purposes, like counter-terrorism and so on. So let's dive a little bit into the data by using Saito Pi. We are writing a very simple query here that basically returns the count of the crimes grouped by type, and we order them. So as you see here, the data is in a tabular form because we return two columns and is properly displayed from the notebook. You can use the line magic in order to extract a data frame and use other visualization, not only the graph. In this case, I will combine the Saito Pi line magic with an heat map provided by Plotty, so we can write our Cypher query here, and we activate the line query, the line magic function by passing -q and the query, and then I render the heat map with Plotty. So it just take a few seconds, and here we have our map. So you can use the line magics in order to then extract the data frame and use that data frame in other visualization library like Plot in this case. But you can also visualize graphs. In this case, we want to check if there is a shorter spot between persons related to crimes. I'm not discussing so much about the meaning of the query, because in this case, I just want to focus on the tool and how you can use it. But in this case, we basically return the query, and the query returns a graph, and so we display a graph inside the Jupyter notebook. And in the same way, you can use the line magic in order to visualize, as I did before, in this case, a bar chart visualization. And here we are extracting a graph instead, a very simple graph, in order to identify clusters. In this case, I want to identify clusters of connection between persons that might be used in order to identify gangs or other criminal groups. So we used the line magic in order to extract.
Sorry, Andrea, to break you in between.
Yeah.
We are running short of time. We need to wrap it up in next 2 minutes.
Yeah, I just finished. It's the last
okay,
bit.
all right,
Yeah.
great.
Yeah. It's the last bit. So you basically can export it to NetworkX and then use the its API in order to compute the triangles and display the results. So that's it, guys. Thank you so much. If you have any question, I'm very glad to answer to them. Otherwise, start the project on GitHub and fill an issue if you need something. Thank you so much.
Thank you. Thanks so much, Andrea. We have 2 minutes, so we can take a quick 1 or 2 questions if possible. So the first question is, where does the cell magic command get the connection details, like URL and credentials, get from?
Yeah, so in the beginning here, I defined 3 Python variables where I stored the connection details, and I used them at the first call here by passing the arguments. So -u, it's the argument for passing the connection URL, -us, it's for the username, and -pw, it's for the password. And then the Saito Pi integration store this connection details internally, so you don't have provide them each time. Okay.
It's cool. One last question: why is Saito Pi used?
Yeah, basically is used in order to, as I said, to to add Neo4j in your Python workflow, it's something that has a goal to make Neo4j more Pythonic, let me say. So the goal is to get closer Python developers, so data scientists, data engineer, with Neo4j, with a simple integration that allows to export data in Pandas data frame or NetworkX graph in a very easy way. And if you want to also display them, also display the data and build dashboards via Jupyter, you can also use it, using it. Okay.
All right, thank you. Thanks so much, and yeah, I think those are the questions that we had for you, and it's almost time. Perfectly timed well.
Okay.
Thank you.
Thank you so much.
Looking forward to having you next year as well.
See you.
Thank
you so much for your time.
Take care. All right, so Philip, I think you can take in the questions, and I will be able to take in the questions in the chat window. And we are there for the last session where we have Dr. Julian and Dr. Goran who's gonna do the session. Dr. Julian is research associate at Friedrich Alexander University, and they both are going to talk about ESG supply chain knowledge graph. Am I audible to you both? Oops. They're just doing some tech check. They'll be back in quick 1 minute. Just give us a second. Can you hear me? You're on mute right now. You would have to unmute yourself.
Can you hear Sid?
Yes, I can hear you.
Oh, perfect.
Cool. Over to you both.
Sorry?
Over to you. You can get started now.
Okay.
Will you be sharing the screen?
Yes, we are trying to share the screen.
Okay.
Can you see the slides?
Yes. Can you switch it to the presenter-only view? Yep, this is better. All right.
We will switch a little bit to. Are we already online? No.
You're already there. That's 3 minutes past your time, scheduled time.
Okay, so we start.
Yeah.
Do you give us a sign when we are?
You're
already. Sorry,
Yeah,
I didn't understand it. Okay, so sorry for the delay. My name is Julian, and this is Goran. We are both from the university, like the Friedrich Alexander University in Erlangen-Nürnberg, and we are both working at the chair of accounting and auditing. Today, the topic is ESG supply chain knowledge graph. That's what we are probably doing most of the time, researching on supply chain knowledge graphs and see the connection between ESG and supply chains. Like I already said, my name is Julian. This is Goran. And
And to give you a little bit of overview what we are doing, it's all for us about data governance in the beginning. We live in a digital world that everyone has a digital life. There's various reasons to look at sustainability, sustainable development goals, and ESG related topics, even when you're working in accounting and auditing. Probably most of you know the Sustainable Development Goals. The founders of the United Nations. It was established in 2015. There's 17 goals, and we want to have a look in detail some of them. This is kind of the beginning for us. We have a new European legislation. It's not passed yet, but companies are working on that, and it's all about the supply chain and the due diligence requirements in the supply chain. You can see for businesses, legal certainty and the level of playing field is very important. For consumers and investors, more transparency would be ideal. And for us as researchers, it would be nice to have a lot more transparency on the supply chain, but also in terms of the quality of the data. So what are we doing? We are working on the supplier lists of Adidas, Nike, and H&M. Those three companies have already published their supplier lists online. You can download them directly. They have a lot of information available for everyone, which is not only the name of the supplier, but also like what kind of supplier, the address. Some of them even publish the owner, or for example, the telephone number. So it would be nice you can already call them and see if this company is already if it's a real company or not, where is it located and stuff like that. And if you have all those information about the supply chain, you can dig deeper and ask yourself some questions. For example, are the company suppliers well distributed? We've had a lot of political issues and also environmental issues. So it would be nice to see, okay, where are the suppliers of the companies? Are any of the companies' suppliers listed in European Union sanctions countries? Are any of the company suppliers located in worst workers' rights countries? But it's not only about workers' rights, it's also about child labor and, for example, environmental issues. That's what we want to look at. And that's why we use knowledge graphs, because we want to know how can we connect data that we have and that we can find to see if the supply chain is good or bad in terms of ESG. Okay, like I already said, we had a look at Adidas, Nike, and H&M. You can directly find the links here. You can download the data and we cover what we are doing. To get a better overview of the suppliers, we just quickly put it into Google Maps and wanted to see, okay, where are the suppliers located? You can see, for example, here for Adidas, it's pretty much around the world. Every part is, you can find here every part of the world, and you can compare that to Nike. This is pretty equal, but for example, if we have a look at H&M, you can see that the whole continent of Americas is not really a supplier. There's one supplier in the United States, but not at all. For example, here in Brazil, Argentina, there are no suppliers.
Yeah, that's particularly interesting for H&M, since they got no suppliers in North America and South America. We can see coming from China through the Suez Canal, H&M would be way more volatile than, for example, Nike and Adidas. These are also interesting points. Quite simple by itself, but considering from an economic standpoint, those are things like also crises like COVID or Ukraine, for example. Those are points that have to be tracked live and considered when thinking about supply chain resilience, for example.
Okay, now we get our hands dirty you can see, okay, we have the Adidas supplier list. We put everything into Neo4j. You can see 3 different colors. Those are the 3 different kind of suppliers Adidas publishes. And if we see on the next slide, you can see, okay, this is pretty much unstructured. You can see a lot of like companies, regions, countries, whatever you can find. And we want to make that structured. So we want to use some use cases. For example, tax paradises. Here you can see a list of European Union's blacklisted tax havens, plus those upgraded to the gray list. Okay, and we wanted to see, are some of the suppliers from Adidas, H&M, and Nike in those countries? Are they active there? This is the graph we get. If you look for the suppliers and match it with data, open available data you can find in the internet about tax havens, tax paradises, and blacklisted countries. This is pretty huge, and you cannot get a lot of information out of it. That's why we want to have a closer look. For example, here you can see Nike on the left and H&M on the right. And you can see that H&M has far more connections to those countries who are like tax haven, tax paradises, or blacklisted by the European Union. And this is interesting. And that's a point, like a starting point where we want to dig deeper inside the topic. Another example is, for example, if you want, like we already said, worst countries for workers' rights or worst countries for child labor. You can see here some examples. You can see Nike, H&M again. H&M has again a lot more connections, and that's the starting point where we want to go really into Neo4j.
Yes, of course, the time is quite limited, so we considered we also pre-processed a query. This time we're looking at the child labor and workers' rights, partially of Nike, H&M, and Adidas. For instance, here it is, as I said, a smaller query. We used GraphXR because we had 79,000 entities, and for this laptop it's a little too much to process. Also considering that sometimes double entities are created. So, well, let's look at the graph. For instance, what happens. I mean, this extension is very interesting in itself. When we look at single entities, we can see here, okay, the primary of Adidas and H&M are quite active in India. This is to be expected. I mean, Nike is also active there. What about this one? This is, well, that's an example of an entity, but the main entity is Pakistan, which is interesting because Pakistan in itself, we talked about like tracking news and everything, and for example, weather data, and we know like Pakistan has been well, a victim of many floodings in recent times. So we could expect like the ideas being more aware of that and thinking about supply chain resilience. I mean, that happens a lot, right? This is a simple query, very simple. Let's say we just want to look at Nike. Simples of the processing it takes. Let's have a look. This is quite fast, and here we see it's way smaller than those of H&M. Only in 2 blacklisted child labor countries. Let's see, for example, here we got, well, India, that was the one we already saw, and I think for the workers' rights, which one would be interesting? Let's see one up here. Guatemala, I think the other countries are not active in Guatemala as far as they easily queried. But in itself, we can see using knowledge graph this is also a very simplistic approach. I mean, we can't compare to companies and their power, but here we can see that we can use knowledge graph to increase supply chain resilience majorly. And coming back to the presentation, here, right? We already had that's also the data we use. Yeah, this is the image we saw. Like, this is where we digged into. And this is just a starting point. Like, we want really to create a knowledge graph as big as possible to have a look at several data points, at several clear points we want to, several points we want to make clear. We want to see, okay, how are the working conditions? How can we find better information, publicly available information? Because you can like search for a lot of ESG ratings, but the problem is we don't know where the data comes from. In terms of research, we have to trust on the ratings, but we can also say, okay, we want to make our own rating because we can see, okay, we can find information about, for example, floods, like environmental issues, about the suppliers itself, because we can now say, okay, we know the suppliers and not only the countries they are in, and we can search in the internet for the suppliers. Like, where is the address? Is it close to a school, for example? Is the company helping the workers to improve life? And that's something we can maybe see by adding like as much information and as much data we can find on the internet to our knowledge graph. Whoever is willing to... Sorry?
Dr. Julian, sorry for interrupting. We are running out of time. You need to wrap up.
Okay. Like, this is a quickly sum up of the points we found out in the knowledge graph right now. This is us. Feel free to call us, to text us on LinkedIn, email, or whatever you can find. And this is the data we already have. And if you, like all of the audience, have some information, data, whatever they want to share, just let us know. We can put it into the knowledge graph, and we are willing to share the knowledge graph with you as well. So thank you, Sid, for keeping us on track. And excuse us for our connectivity issues.
No worries. That's all good. Thank you. Thanks so much, Dr. Julian. We have 2 or 3 minutes, so we can take in 1 or 2 quick questions. So there's a question: do you think OTAs can benefit from knowledge graphs?
Can we switch back from the presentation mode to the... So we can see...
Yeah, you need to just switch to the StreamYard.
All right.
So the question is, do you think OTAs can benefit from knowledge graphs?
We are not sure what OTA means. Excuse us for not knowing. English is not our primary language. What's meant by OTA?
All right, no worries. I think that's about it. I don't have any more questions in the chat.
Sorry, Dimas, for that. We will Google that and just let us know what OTS is, and we can answer the question.
Definitely. The chat is open, so feel free to drop into the chat window. And yeah, and we look forward to having you the next year as well.
Thank you.
Thank you so much.
Thank you. Thank you.
Thank you. Bye. Take care. All right. So this brings us almost to the end of the notes, but there's one more session left. So I'll not keep you waiting. I'll just want you to wait for the next 2 minutes before we go live on that.
Hello, everyone. Welcome again if you've been with us for this entire time from the beginning, or welcome now to Malmö, Sweden, one of the headquarters of Neo4j. We're here in the offices, and I'm Andreas Colliger from the community team, and I'm sitting here with the CEO and one of the founders of Neo4j, Emil Ephraim.
How's it going? Great to be here.
Emil, thanks for sitting down on the couch with me again. This has been an amazing, couple of sessions. We've had now, I don't know how many hours it's been, 12 hours of sessions running across the planet. And really just an amazing time. Thank you, everyone who's been speaking. The sessions have been amazing. I feel like this has been one of those occasions where I feel comfortable canceling Netflix because I just want to watch the recordings of all the sessions that I've missed. I just want to go back and there's so much good material. But this session is about questions for you, ask me anything sort of style questions. We have some great questions already lined up if people haven't asked questions yet. First, I'm going to start with some slides to show you how we're going to run things. So let me cut over to our slides here. So hi, Emil and Andreas, also known as ABK. And here's how this is going to work today. You've been in the venue, the virtual venue that we have called Hopin. If you go to the reception tab on the left-hand side, you'll see on the this kind of the sidebar on the right, there's a tab called Ask Emil. Click on that, ask a question, upvote a question that's there. We're going to try to answer the top voted questions over the next 20-ish minutes. But I promise every question that is asked, we're going to answer, if not live today, now. I'll get back to you later. Somebody else will get back to you, and we'll make sure that everyone who asks something will get a good answer for whatever you've asked about. But for now, we're going to go into the top questions that we have here. And Emil, actually, this is when we did the earlier Q&A, we had a bit of history of Neo4j, the name, where that came from, a bit of the origin story. This is also a part of the origin story. A lot of the speakers and people in the audience have had what we call a graph epiphany. They've realized graphs are pretty awesome. What was your graph epiphany that got this whole thing started?
Yeah, it's a good question. So I guess it was the Americas that kicked things off yesterday with nodes, right? So we did the version of this session last night here, and talked a lot about kind of the origin story and the name and all that kind of stuff, right? I guess this one, a little bit of a different angle on it. So I got started, I was programming since I was a teeny little wee lad, at whatever, 10 years old. And I've been programming for half my life. When at 20, I had a gap year because of my military service and before starting college, and joined a tiny little company, except they didn't call themselves a tiny little company. They used a weird word for it, which is they called themselves a startup, right? And we were building enterprise content management systems. And it was a small company. We were 12 people, 5 in the engineering team. I became the CTO. I wasn't one of the founders, but I became the CTO of that company. And we had a bunch of problems with the database. And even though I was 20 years old, I've been programming a lot. And in all my projects, I think without any exceptions, the database had been a help. It had been an accelerator. It took this big, gnarly problem, which is how do I store my data and make sure that it's there? Absolutely, no mess ups at all. It's durably there. Make it queryable in an easy way. Make it accessible across concurrent transactions, concurrent users, mixed read-write workloads. That's a lot of hard work, right? And if your job is, in my case, there's a lot of gaming. Right, when I grew up, I built a lot of kind of multiplayer text-based games. Right, this is a long time ago now. Right, that's what I wanted to focus on, not how do I actually get it to store on disk. Right, and so then I pulled in whatever database we had at the time, which was typically MySQL or something like this, and it always accelerated my development because I could then focus on building the game, not on that hard stuff. Right. So then fast forward to this small startup that I joined, and we were building enterprise content management systems, which is a lot of connected data because you have files that sit in folders. Those folders sit in folders. And then we added symlinks, symbolic links, which I guess in Windows is called shortcuts, right? So this folder could actually have multiple parents. And all of you in the audience, you probably know that that's mathematically where if you have nodes with multiple parents, that's mathematically when a tree turns into a graph, right? As we tried to shove that into the relational database, and it kind of worked, but man, was it painful. So remember, at a moment in time, there were 20 people in the engineering team. Half of them spent the majority of their time just fighting with the relational database, right? And that's when we realized something was wrong. This is just contrary to all of our experiences from before. And of course, today, whatever, 20 years later or something like that, as an industry, we have a very crisp understanding of this. We have a clear and good language for it. The abstraction here is there's a shape of data, and there's a mismatch with the representation, with the abstractions, with the building blocks, right? We have a lot of connected data. We try to shove that into tables, right? That's ultimately why it took so much time. It took us like a year to figure that out, or like root cause analysis and asking kind of the 5 whys a bunch of times, right? And ultimately realized that, yeah, that was the problem. And so that's when we realized, you know what? What if there was another database out there that worked exactly like we were on Informix and Oracle at the time? I moved off of MySQL, but that worked exactly like Informix or Oracle. It was kind of scalable and performant, had transactions, multi-users, a query language, all that kind of stuff, but just a different abstraction, a different data model. Instead of tables, what if we could work with information and model our data with nodes and relationships? And so that's ultimately, that was the trigger that, down the path led us to build what today is Neo4j.
Amazing. So born out of need, and then you thought, let's build our own database. How hard could that be?
How hard could it be? It turns out decades later, it is pretty hard, right? And so it was our own need. It was definitely scratching an itch that we had. I think there's one strategic insight that we had, right? There's a lot of flaws in our thinking, and we took on something that was much harder than we expected. It's kind of the classic thing. If we had understood back then what we understand now about how hard it is, we wouldn't have taken it on. All kinds of naivete like that. But I think there's one kind of moment of clarity that we had, though, which was a very, very simplistic view of the world, which is if you think of a chart with an y-axis and an x-axis, right? And the x-axis is actually, t-axis is time, right? The y-axis is how connected is the world. And you take an arbitrary moment in time. Now, we're here. This is how connected the world is on the y-axis, right? As we move forward in time, will we go up or down? In other words, will the world become more or less connected? And just even that framing is so simplistic. Like anyone, a child would say, of course, everything can become more and more connected over time, right? And so a consequence of that is, if the world is becoming more connected, what is data? At this conference, we're talking a lot about data. We're talking a lot about information. But what is actually data? Well, data describes the world. It's a digital representation of the physical world. That is what data is. And as the world is becoming more and more connected, data will become more connected. And so we didn't know how many other people had the same problem that we had. We figured there's got to be other people out there. Is it 5 of them, 500, 5,000, 500,000? We have no idea. But we knew that tomorrow there's going to be more. And tomorrow there's going to be even more, right? So there's a lot of scratching our own itch, but then we had this insight, or at least belief, that there was going to be this wind behind our back where more people would have the same problem that we had tomorrow and the following day.
And then the internet, and now the metaverse someday, like to your point, like the world is becoming more connected. That leads a little bit into this next question then from Louise Almazan, who asks, so given that background and that sort of insight, that intuition that like connectedness is growing, what do you see for Neo4j and graph databases in the next 5-10 years? Which problems are there to solve ahead? And 5-10 years, who knows? But
it's a good question, right? So if we're right about kind of that initial intuition that the world is becoming more connected, right, which I believe we are, then over time, over the next 5 to 10 years, we're just going to see more and more use cases that benefit from initially and over time require graph databases. And there's actually a couple of ways to think about that, right? One is entirely new things, right? So when the Panama Papers happened, right? Like that is like no one could have done that before at that scale without graph databases. It was not doable. So on some level, that's a new use case. But maybe even more present, I think, would be existing use cases that over time benefit from and then ultimately require a graph database. And my most recent favorite example of this is supply chain, right? So what is a supply chain? A supply chain is all the distribution that's required to get the parts for you to build your physical product, right? And 10 years ago, right, if you're building anything physical like this, right, you might have a supply chain that is 2-3 levels deep, right? If you wanted to digitalize that and analyze it, you can shove that into a relational database. You can do 2-3 joins. It's doable. It's not great. It's not a fantastic, but it works, right?
Yeah.
Fast forward to today, and anyone who's producing physical goods is tapping into this global fine-grained mesh spanning continent to continent that is 20 levels deep or 30 levels deep, right? Is it a year and a half ago now, summer 2021, the Suez Canal was blocked for a week. And the entire global supply chain got gobbed up because of that, right? Like, how can you analyze that? Well, if it's 20, 30 levels deep, you can no longer use a relational database for that. That is not doable. You have to use a graph database or put it all in memory in some kind of cache and really re-implement an in-memory graph database. Those are your only options, right? And so if you take a step back, what's happened there is that that's not a new use case per se. It's an existing use case. We're solving the same business problem. I want to understand my supply chain. If something happens, how will that affect my customers, my physical retail stores across America or Europe or Asia, right? It's the same business problem that we're solving, but because the world has become more connected, that use case now benefit from and ultimately will require a graph database. So when I look out over the next 5 to 10 years, there's just going to be more and more of those types of use cases. So that I think would be the first vector of change. The second vector, everything that I've talked about so far has really been with the framing of a developer, right? That's my background. That's how I grew up. That is the first 10 years. That is not all we did, but by far most of what we did, right? Neo4j as a backend to the world's applications, right? A really exciting newer area for us, of course, is the growth of graph data science.
Yeah.
And that's an entire, we don't have too much time. We can talk for 5-10 minutes just about that. But I think that like the rise of graph data science over the next 5 to 10 years in the world of graphs is going to be as impactful as that first vector that we discussed.
And looking through the sessions that we've had in the last couple of days and the ones that are coming up still in Europe later, that balance is present, right? Like there's like huge amounts of application development in all domains, and then graph data science, equal partners like through all of this stuff. It's amazing to watch. Okay, stepping back a little bit and getting a little more personal, if you would, about Neo4j. This next question from our good friend Michael Hunger, whose name I've seen in the conference here and there.
I recognize that name somehow,
He asks, so what were some of the highlights for you personally as a Neo4j CEO? And then as a small follow-up, do you still code? Technical founder? Are you still?
He's putting me on the spot.
Do you want live coding session? Is that what?
Man, highlight of my house. Man, there's just so many. This has been the journey of a lifetime, of course, right? Like the only thing that rivals it for me personally is I'm a dad. I'm a father of 3 girls, as you know. My middle daughter and your daughter were born within same month.
2 weeks.
Is it 2 weeks even? Yeah. That's the only thing that can rival like this exceptional journey. It's very hard to call out like one particular thing. Probably the Panama Papers would be very, very much high up there, right? And so for those of you who don't know it, it was the biggest data journalism leak in history. It was the biggest news story of the first half of 2016. The second half of 2016 had Brexit and Trump,
Less fun, yeah.
you know, the election of Trump, right? But the first half, that was the biggest news story of 2016. Investigating a lot of people using offshore tax accounts for avoiding to pay taxes, basically. And several prime ministers in the world were in there, were uncovered, thanks to a lot of hard work by over 200 journalists across the globe. And they are on the record saying that without Neo4j, it wouldn't have happened, right? So that one is, of course, massive. But there's over 20 independent projects using Neo4j to find the cure for cancer. And if I have to peel away everything, that's probably the most motivating thing for me. Every single one of us here, you, me, everyone on the call here, without one or maybe two hops out in our own personal graphs, we have people who have been impacted by cancer, right? And so if there's anything we can do in any way, in shape, and form to help contribute to finding the cure for cancer or a cure for cancer, that will also obviously be absolutely exceptional. So that probably is what I would say. Like the impact we see from our technology in the broader world is very much high up there.
And I mean, that's such a unique sort of pleasure to take. Like, okay, this is a technical problem that we're solving, and you know, in the early days, you hope that other people have the same kind of problem, that this is successful, but it's gone well beyond that. It's like, oh, actually, there's a social good that happens because this exists that you couldn't have conceived of. Like maybe conceived of, but like, oh, wouldn't it be neat? But like, it's happening.
Yeah,
the world is better because of this.
And this is one of the very just intellectually interesting things about building horizontal infrastructure technology, right? Because ultimately, if you build a vertical SaaS application selling into HR, solving a specific business problem, like that can be very satisfying because you have a very direct connection to the people being impacted by that. For us, though, like we don't have that direct connection. We're typically embedded in a project that then solves a particular problem, right?
Yeah.
On the flip side, though, the variety of use cases, it's just exceptional, right? And so I think that on the code thing, I want to make sure I was trying to avoid it. But yeah, sadly, Michael, there's very little time for me to code these days. I still play around with our products quite a lot, but I never have time to code, and I don't even know if I know how to do it anymore. I'd like to think that I can still code, but I'm very rusty.
See code when you see a presentation and look, oh, there's code, and you recognize it.
And recognize
I can still read.
Yeah, but there was an interesting internal presentation from when a couple of months ago when we talked about Neo4j 5, which, by the way, I hope you've checked out Neo4j 5 because holy crap, it's the biggest release we've done in 3 years. It has so much amazing stuff in it. But anyways, there was an internal presentation a few months ago when Ivan, the lead PM for the database, was talking about all the, not even all, 5% of all the goodies in Neo4j 5 because it's such a massive release. And there's one slide when he showed some driver code, and I was sitting there in the audience staring at it for like a minute, trying to figure out which programming language it was, and ultimately failing.
Ouch.
so that sucked. It's like, if you needed any more evidence of how post-technical I've become, there you have it.
Is that Rust? That's a language?
Is that Python? OCaml?
We have time for maybe one more question to kind of get through, and I'd love your reaction to this. So we ask people we've had amazing content, lots of really great talks, lots of good speakers. What would you love to hear more about? One of the sessions that came up that I thought was really worth digging into was about, it was with our friends at Databricks. And I say that genuinely friends, right?
Yeah, totally.
And the session was Connected Data Lakehouse, Neo4j and Databricks Reference Data Architecture. Okay, what can you share with us about data lakes, houses? what are the terms even?
Oh man, yeah, this is such a dear topic of mine, right near and dear to my heart. I can talk for hours about this. But in the few minutes that we have, maybe a couple of things that I'd like to call out, right? One is, I only alluded to this before in the 5 to 10 year lookout, but the impact of relationships and data on the broader universe of machine learning cannot be overestimated. It's going to be a massive thing over the next 3 to 5 to 7 years, and we've seen that at bigger organizations like Google, for example, shifted their entire machine learning away to what they call graph-based machine learning 5 to 7 years ago, which is basically saying, you know what, we're not just going to look at isolated data points, we're also going to look at the relationships between them to inform our predictive models, right? And so they did that 5+ years ago, and there's kind of this notion of where Google lived 5 years ago is where the rest of the universe lives today, right? Because they deal at they kind of live in the future with the scale that they're operating at, right? And so that's kind of the promise and the premise behind our graph data science product, right? Which I hope many of you on the call are familiar with. And so then, like, how do you then marry that up with the analytical data stores, right? So I think of the Snowflakes and the Databricks as in the broader category of analytical data stores, and I think that's what this question alludes to. And there's a lot of interesting things going on there. We have a close partnership with Databricks, which helps put together the broader data lake architecture that they have with an instance of Neo4j or a cluster of Neo4j and graph data science, and make that operate really, really well together. We've also started talking more recently about the knowledge lake architecture.
Right.
And the knowledge lake architecture, I'm personally very excited about, because it's a way of reducing friction for adoption of GDS, of graph data science, inside of the broader enterprise, where you can build up a graph-shaped replica of data you already have in your data lake house, right? In your data lake house, or in your data warehouse, right? Whatever instance or maturity you're on for your analytical data store, architecture. And you can reshape that in graph form so that you can easily tap into that for all your machine learning projects. So we call that the data lake house, right? And so that's a really important initiative that we've been spending a lot of time on recently.
So this is part about the overall growing and maturity of the category, dovetailing with other categories, and like all of it, is part of this connected future. Really, it's a connected future of just data, but also of technologies. This is where we're going to live.
That's right. And then very importantly for us, right, is the whole, it's both for developers, but now also for data scientists and data engineers. And I think that's a really exciting part about the broader platform that we're building out.
Working hand in hand.
Working hand in hand. That's right.
All right, fantastic. And always a pleasure to hear your thoughts on anything, life, the universe, and technology. Thank you for your time today. Thank you, everybody, for tuning into this session. This is the end of this phase. We're going to be moving on in a couple of hours. Europe is going to wake up. Some of Europe, I guess, is already awake. So come back for that. If you're up for it, we'll be back for another session as well. Thank you so much, everybody. Take care.